already is I buy a compact type lah. Means you can it's already include analog and also digital. Together.
Just came.
Just came. For next week's training. So I think try to go up and see. But yeah. Okay, so before we continue on, any question?
Yes. Actually, yes.
Okay. What questions?
It's actually regarding the wiring.
Wiring. Okay.
Yeah. 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 Could you come over? Yeah, I'm not sure. Okay, so 24-volt DC to 1 amp.
24 or 0?
Sorry, 0.
So we connected 0 volt, right?
Yeah.
Okay, so if you want to test it, power off please. Right. Okay. So what is the question?
No, it's more like why here we need to connect L and M, but then up there you only connect M.
Okay, only input Y one. Okay. So you see only for inputs, right? Okay. How it works is okay, I will explain that. And output Y is like that. Okay, I have another model. That one also I show you. It's a relay model. Okay. This one is a relay model. You see output only N. Okay.
Just double check the PLC. One good.
Yeah.
Okay. This laptop also you can use, huh? It's not quite powerful, huh? Unless someone wants to use. One extra.
Software.
GXbox 2, Factory IO, and SOPC, and what the S7-1200 one. Microwave. SIMATIC manager also inside.
For input, right, you have 1 amp, right? Okay. So just one. We talk about only one input, okay? We see how it works, okay? For inputs, so you need to give from the power supply. Okay, 24 or 0. Okay. Then this one go through a switch. So means can be anything, okay. So let's say here is 24, here is 0. If it is 0, here is 24. Okay, must be plus minus lah. Okay, why? Because inside here they will have like a optocoupler. they call optocoupler, like diode, like a LED. Okay, like just a concept like LED lah. Okay. So you need to so like LED means you need to give positive, negative. Then only you can light up, right? The same concept. So if you give 24 volt here, then the input must be 0 volt. So it can on the optocoupler. See, this optocoupler is the one that sends the value to your CPU as 1 or 0. Okay? Okay. So if let's say I have multiple inputs, so what I do, this side I must look. That one you understand? Because all must be, so let's say the 1 amp you take from one power supply 1, it means all the other inputs must be from the same power supply. Cannot be the other power supply. Let's say for example, number 3, you want to take from another power supply. Even though you're using the, let's say we connect 24, right?
Yeah.
I want to take from the other power supply 0 volt, it won't work. Why?
Yeah, right.
Because if you want to light up a lamp, right, must be from the same power supply. Let's say battery, for example. If you take a battery to turn on a lamp, positive, negative must be from the same battery.
Yeah.
It cannot be like positive from one battery and negative from one battery, unless you loop the battery, you join the battery.
Unless you connect number 3 to the there.
No, cannot.
Also can.
Okay, can understand? Okay, so must be from the same power supply. Okay, for example, let's say I have a lamp. So this one is positive from power supply 1. So this negative must be from the same power supply 1. Right? It cannot be another power supply. You cannot turn on the light. I think that is the concept. Okay. So if I want to number 3 also must be from the same power supply. That's why they use a bigger power supplies. Depend on what is the they will calculate everything. If you want to buy a power supply have an amp, right? How many amps the power supply? Okay. So you need to calculate all your input output, the load, how much it used the current. Then only you can buy a power supply. Okay? Input, okay? That's why it's only 1.
Yeah.
Okay? Now for output. Output got 2 types. One is DC type. The one with you is a DC type, right? Because it's a DC. Right? Okay. So you have 3L plus 3N, 1 output. Okay. So we have one power supply, take 24 volt, and here 0. So we need to understand how this one works. Output DC, it means the output voltage from my output goes here is 24 volt. Okay, so it means output PLC, how PLC is not a power supply one. How to supply 24 volt? Right. PLC just can on and off only the output. It cannot give you the voltage. So inside here, how it works is it's like a switch inside actually. Like the concept one. There's like a switch. You take from the 24 volt. Okay. So like a relay, relay, right? How the relay works. So relay will have a coil and a contact. Okay. So it means your PLC will energize the coil. Okay, that's how the word. You don't go for the logic. Okay. So the PLC, so for this they will have a coil, or if you're what? If DC means they will have a transistor inside. So the transistor will turn on. When the transistor turn on, this one will close.
Oh.
Okay. But why they need the M? Right? 0 volt. Okay. Because like I said, to power up the transistor. So what happened? This one is inside. So what happened? This one and this one go to the. So let's say for this I have a transistor, right? That is like for example. Something like this. So this one will go here and this one will go here on the transistor. So when PLC turn on the transistor, I mean this supply to transistor lah. So when turn on the transistor, it can close. Then here will be 24 volt. So to power up a lamp, I need 0 volt. So I connect here. Because very simple lah. The PLC need a source to give out a voltage. So the PLC, so you need to give the 24. Any PLC say, all PLC say. I can show you later. So you need to give voltage, then only I can give you the voltage.
Okay, so 3L.
L plus means, okay, another thing is in Siemens one. Siemens L and L plus M. So L is 230 AC, N is neutral, L plus is 24 DC, M is 0 DC. Okay? Only the input M can be both. Because if you see other PLCs, they call it COM. You can see here. Can you see? Other PLCs, they call it COM. Means it's a common, they call common. Common for the input. So means that, it's also same. If the COM you connect 0 volt, the input must be 24 volt. If the COM is 24 volt, the input must be 0 volt. Okay? Okay? Now, let's I give you another one, right? The relay type. So see, relay type also same, the concept. Okay. Output relay type. So relay type, you see only L. Only L, right? One L, right? Then 0, 1. Why? So this one is the same. This one is very, very straightforward. Like this one. Like internally, similar to this. Similar to this. But this one you need to power up the transistor. This one you don't need to power up because it's a relay type. So internally build a relay. Internally they have a relay. Okay, so your PLC work is to energize the coil. So here will be like first. So here you can connect 230 AC 24 DC. So this side can be neutral or 0 volt. Depend on what you connect. So relay can go up to 230. You can see here. So you see DQ, they put 4 times relay, 30 VDC or 250 AC. And maximum lah.
And also, either one connect to 0. Connect 0B. 0B.
Yeah, of course lah. If you connect AC, then you neutral lah. If you connect DC, then 0 volt. Okay. You clear the one?
I think so. And then here 3M must connect to and connect to 0 volt.
Yeah.
And then L
24.
All together with the
That one you forget about it. This one you just forget about it. So we need to power up the output source. For the output, you need to give supply. Then only I can get the voltage. So since I give, since my this one is the, can you see 24 VDC output. Okay. Here is just show relay output, right? So when you show 24 VDC output, so the output will be 24. Go to the lamp, right? So one by one, right? 24 go to the lamp. Okay. Then the other side must be loop, right? So this one must be 0 volt. So this output com will be 0 volt.
So all this is 24.
Oh, you forget about this one. This one is different. This one is different. So for this, for the lamp is from the PLC go to the lamp. Okay. Then the other side of the lamp I loop go to the power supply. Okay. So that is this one lah. I didn't straight away go because I can. Why I do like this? Because any PLC I can put it here. Okay. Now for the input, okay. For input here there is no voltage. It's just a switch only. For the input, there is no voltage here. It's just a switch. So it depends on what you connect at 1 amp. So if at 1 amp you connect 0 volt, then you need to supply 24 to here. So the loop cable, right, must be 24 volt. So when I press, the 24 will go in.
So this L and M here is another one. Is to
Power the module.
After power the module, still need to power the input.
Yeah, input and output is different. Okay, got it? Yeah. Any other questions?
No.
Okay. So yesterday we do the maths, SCADA later also we do something. Okay, we do some additional functions. Okay. The counter, the match function, all okay. What we do today, we see what is FB and also FC. What's the difference between function block and FC? Okay, okay. So you click new project. Day 4 lesson 1.
I don't know what thing specifically are you attached to?
you okay, actually what name let's say like motor controller, for example, simple
Motor control.
motor control. Okay, okay. Now at first, no need to do it. So first you do normal program, like start stop motor, simple. Okay. So this one we want to see what's the difference between FC and FB.
Yeah.
So you haven't created the names, right? So you just click here. Okay. I0.0, I0.1, Q0. Then you latch. Okay, just save. So this one you call in the main OB1. So I don't want to test, you know how it works, right?
Yeah.
Okay. You go to add new block. Okay, you see FC, right? No, FC is function are code block or subroutines. Okay. So just now we use is a subroutine. Now I want to use as a code block. Okay. So this one is, let's say you put valve control. Okay, clear. Okay. So this one like I said subroutine, right? Code block means okay. You click here the block interface. So this block, they have like internal input, output, in out, temporary constant, like internal taggings. Okay, so you do first, then you internally you can understand. Okay, what you do in the input, you put start, stop. Okay, then the in out, so output it won't work. In out you put the one. Okay. Now you do a program here. Yes, normal program is like this now. So you see, you have two types of start, right? So this start stop motor is actually from the PLC tab. The purple color, the blue color means is inside this block. It means you only the start stop valve only can use for this FC only. Okay, okay. So you do that. Okay, you latch it. Okay, now, so now you see don't have any IO, right? Don't have input product. Okay. Now go back to the main. Okay, you call the on control. Yes. Can you see? Now you need to put the IOs.
Okay.
Okay, so this is mean code block. Means you create a coding, then you make it as a block. Then the block you multiple time you can use. Like addition lah, for example, max function, right? So actually inside that there's a coding, right? Like a timer also. Inside there's a coding. Okay. Then so every time you put a timer, you give a different name, then you run. So the same timer you can use multiple times. Correct. The same concept here. So let's say I have 10 valves. So I don't need to create 10 lines. So I only get one logic, make it into a block, then the block multiple times I can use.
But the text only to
Yeah, new text. Yeah.
see the size.
Yeah. Then of course, because it's IO.
Yeah, so that means this one
Need to give put
then
it.
you see the grade new one.
Then put it I 0. There's no 0.00. Okay, 0.2. No, it's a O.
Oh.
0.2. Okay. Then I 0.3. Then Q output Q 0.2. Then 0.1.
Okay. Okay, so if
You add what? Put it beside here. Okay. You put I 0.4, 0.2. So you can rename this one. Then when we do a rename. Click here. Right here, like rename. Okay, you put start V1. Okay, stop V1. Okay, valve 1. Same. Start V2, stop V2, 1.
this internal tag is just edit this thing, this name.
Yes.
Oh. Okay.
So internal tag is just inside because why? I mean I need to have an internal tag that only I can do the program logic. So that's why the internal tag you need to put like valve 1 or valve 2, like a common name. Then I can use multiple times like this. Okay? Okay, so means this is called code block, this is called subroutine. Means inside here I create a program that is called subroutines. This is a code block. Even this code block I can call in the FC also. Okay? Alright. Okay, understand? Now, function block. Okay, wait. Function block is here. Function block are code block. Means similar like just now we do. But they store their values permanently in the instance data block. Okay? Okay, I will tell you what is that. What do you do? Off control, okay, conveyor control. We do the same program. Okay. Okay, do the same thing. You bring it down, yeah. This one got so many. This one got input, output, in out, static, temporary, constant. The FC don't have static. Okay, I'll tell you static what we put in the static. Okay, just put start stop. Okay, here output enough. Okay, why? Because in the FC, if I choose as an output, I cannot latch it. Okay, it means I choose as just now we do like this, right? Start while then while we dash, right?
Yes.
Okay. Inside the FC, if I want to do like this as a output and also like a contact, I need to choose input output. If I cannot only choose output only. If output only means I must use like this only.
Okay.
Okay. So but FB no problem. FB can do like this. FC cannot do. So if I do in the output lah. So that's why in the FC I need to choose input output, in out.
Oh. Oh, just now in FC valve is in out.
Yes. In out.
Okay. Why FC can FB cannot? Right. Yeah.
No, FB can. Why FC cannot? FC cannot because the style, like I said, is more to subroutine only. People very rare use as a code block. Then because of that particular limitation of that.
Okay. Never mind.
You see, if we do first, then you can understand why. Output, input, conveyor. Okay. Now here, we open. This normal program to do. Same thing, okay. Go to main.
Yeah.
Go down and put it. You call the FB. Wait up. You see, when you call the FB, so it is easy. If you call a FB function block as a single instance, the function block saves its data in the data block. Okay. So let's say conveyor control 1. Okay. Right. It's the same thing, right? Okay. But only different is because we choose valve as an input output, so it will be like this lah. Okay. If you choose output, still be like this. Okay. But what is the difference? You take one FC, just put it beside you. What's the difference? Number one, this one don't have BB lah.
Yeah.
Right, okay. Number two, you see, all these are you need to give value.
Yeah.
Right. This one, if you didn't give also no problem. Why? Because this function block, right, it will save the data inside the DB. So you go to DB. So the DB keep the data. Okay. Then the DB will keep the data, means keep the values lah. Okay. You go to main. Okay. So that's why if you didn't key in also no problem. Okay. Now you close this. I mean delete this. Okay. So FC you need to key in all, right? So okay, why they do like this? But not normally they don't. I mean, the DB, right? Not for this lah. Normally for values, like timer values, all that lah. Later I show you. Later we add timers, then we understand. Okay. The concept is very simple. If you're using function block, the function block will have a DB. Okay, means it will save the data inside the DB. Means even if you reset or something, right, the value can be saved in your. Okay, this one don't have. This one is 10 alone. So normally when we do program, okay. So let's say we have a valve, like this is our example, valve control, and both the valve is all okay. I mean all the I/O is there. So I do like this. Okay, let's say I have a conveyor control. Let's say this conveyor, right? Then one conveyor I have a motor trip. Another conveyor don't have motor trip, right? So for one conveyor I can add the motor trip. Another one I just leave it empty also. Why? Because it will save the data in the DB.
What motor trip?
No. Motor trip means it's like an input. For example, okay, you go back to the. You just key in some I/O here.
New one or?
Just put I 2.0 lah. 0, I 2.1, then Q 0.3. Okay. What do? You go to FB1. You add another input.
Yeah.
Conveyor trip. Okay. You add here, normally close. Conveyor trip. Update block. Okay. So let's say you put I 2.2. You add another FB beside here. This one you just put conveyor control 2. For this you put 2.3, 2.4. For trip, no need to put. Here you put Q0.4. So you see, I have 2 conveyors. Okay, let's say for 2 conveyors. So normally they don't do simple like this, of course, a very big program. So for conveyor number 1, they have a start button, stop button, and a motor trip, like conveyor trip. If overload, it will trip. So you have a contactor because the PLC will energize the contactor. Okay, so if the contactor trip, then you can use the signal. You can use it as a PLC input. Okay. So let's say for conveyor 2, right, you don't have the trip input, so I can leave it empty like this. In this case, I cannot leave it empty, so I need to put something.
Yeah.
But if you see the logic, you can just put one memory there also. Right? Okay, but that is not a difference between FC and FD. Okay. Now we want Okay, wait, okay, wait. So this timer, earlier, like yesterday all we only have one, right? Now you see got three. Okay. If you call the function block as a single instance, it means if you use this one, it means it will create another DB for the timer like normal. Okay. If you choose either one, if you share the DB with the function block, it won't create another DB.
Okay, yeah.
Okay, it will share this DB, so it won't be another data block. Okay. Okay, what is between? You see, if you call the quantity instance, says the data block of the calling function block, not in its own data block. So if you use this one, so this allow you to concentrate in a single block lah. So no need to see the timer values all that. Okay. This one is actually it's also same. Okay. It's also same, but if this one is this gives you option defining block during runtime. Means if I choose this one, then later on I think okay for this timer I want to create another DB, then I create additional DB. Okay, for this one I don't need to create. So normally I use this one because for timer all don't need to create additional DB. Okay, just put timer. Okay. Now, then you put here normally first. The timer, timer dot Q. Timer. Yeah, you see the timer. Yeah, dot Q. Dot. Okay. No, I think something wrong. You erase this. Okay, you choose this timer. Yeah. Q. Okay. Because in front of it must have the hashtag. Okay. Means the timer output actually you know right yesterday we use. Okay. Now for the timer value, right? Let's say both the conveyor have different values. So I cannot fix the value here. Like T hashtag 10 seconds. Okay. So I need to do something like yesterday we do like the D, right? We use the MD here. Okay. But now what I do, you see timer go under static. Can you see?
Yeah.
So timer, counter, all will go under static. In the FC don't have static. So what happen? If the same thing you do in the FC, right? If we this one will have their own DB. Okay, because FC don't have DB to share. Okay. Now, okay, for this one you go up here. You put timer in. Okay. So what is the data type for this PT?
Data type.
Time, double integer, double word, right?
Yes.
You choose time. Just key time. Okay. Then at the output, timer run. Same time. Okay. Now we go back to main. You just save it. Just, okay. Update. Right click. Update block call. Okay. So update. Okay. Now, actually now I can give value here. So let's say you put 10 seconds. Okay, the other one also like 15 seconds. why got error?
Yeah.
Wait. It's a warning, okay. There's an error here. This is warning, huh? You see.
Yeah.
It shows input or output values not exist in the configured hardware because you put 2.0, right? It's not on the hardware. This one something wrong. Where is it? You click it. Data type is incorrect. Okay, go up. Oh, you didn't use. We get a timer in and out, but we didn't put here. Timer in and timer out. That's right.
So what are we assigning?
Timer. This one we created one. The timer in, yes. Then this one timer out. Okay, you see, okay, good. Actually, we did a mistake at this helpers. Actually, just now we didn't put these two up. But how can I add them? Okay. Just now we didn't add these two, right? We just created that.
Yeah.
After we create, you go to main. You update this, then it's come out here, right? This timer in and timer out.
Yeah.
Okay? These two. No, this one is close first. Okay. What I mean is, just now we add the timer in and the timer run in the internal tab. After that, we didn't modify our program. We straight away come here, we just update the block call. After update, we got this timer in and timer run. How? Okay? So it means that whatever you see here is not depend on the logic, it's depend on the internal text. Whatever you create input output, it will show here. So it means if you didn't use in the logic also don't care, it will straight away show here only.
And this one is FB again.
FC also same both FC and FB. Both FC and FB, whatever you see here is depend on the internal text, not depend on the logics. Okay, can? Right. Okay, now you download. Okay. Now monitor. Okay. So it just stop this one. I 0.2. Then 3. So we on. So can you see true? So true lah, right?
Yeah.
Okay, you stop, then only off. Then become false, right? Okay, got it? Now you put up. So this one is the same thing, okay?
Yeah.
Okay, now this one 10 seconds, 15 seconds. Okay. This one you need to click on the name here. Name.
This one.
Tank 1 is the name here. Modify to 1, modify to 0. Okay, modify to 0. No, modify to 0. Because it's a push button, right?
Yeah.
So it can run for 10 seconds, it can couple right? Okay, so this is the same thing, right? The other one is the same thing, run for 15 seconds, cut off. Okay? Okay, now okay, this you take up you delete this one. Delete the value. Enter. 0 Now you download. Okay, you see 15 seconds is still there. Right? Why? Because all this data, right, the false, the number, value, all will be saved in your DB2. So even though here you erase the DB2, still keep the value. You go to DB2. I think this is DB2. Yeah. Actually, you can monitor. Yes. Still keep the value 15 seconds. Okay, so that is the function of data block, to keep values, datas.
So why do we need this?
Because sometimes we want to take the data to send, for example, when we use this, to take the data, to keep the value, to save the values of that. So later on, you can access to this DB to extract the value. You don't need to go to this block to get the value. So this is just a template. Timer value, right? So normally what they do, they not timer, some other values like temperature, motor speed, something values or calculations or that. Want to extract the value. So you need to go to the OB1, find where is the function block. No, you straight away go to this DB to take the data.
This data, is it an input or is it you just fix yourself?
It's like a memory, like an M.
Okay.
Data block is similar like a M. But this particular data block is dedicated to the function block only. So it only saves the function block's data only. You cannot save like your own data. If you want to save your own data, you go to add new block. Go to data block. See, the data block save program data. That's all. Like I said, this will save values, data. Okay. You can use global. Global means you need to create all the data. If you're using this one, means, can you see conveyor? It means you're creating data block that is only for the function block. Means only so the data is saved from the function blocks. Okay. Global DB later we do that. Okay, global DB similar to your memory M. Similar to memory okay. So whatever you want to do, you can do in the memory. Let's say for the HMI, right? Remember yesterday we do the start HMI, stop HMI, we get the memory. We get a tough time to check which memory you want to use, all that, right? Actually, you can use data block. Instead of using memory, you can use data block.
How does it make it easier?
So no need to worry about the addressing. So we
just pull money.
yeah, because just create data block. I mean this one like global so then it become like a PLC text, right? Like a PLC text. Then you key again. Start, stop, timer input, timer output, counter value, counter input, all that. Then you can use that in HMI. Okay? Can? Okay. You cancel this one. Okay. So are you clear with the function block and the FC? And the DB? Why DB? Another question is okay. Go to main OB1. Can you see the memory reset, right? Okay. Memory reset will reset the memory value, but not the data block value. Okay, we try one. Okay. Okay, you go offline. Okay, what do? You put it here. Here, a max function. Okay, addition. Okay. Then some choose integer. Then you put MW0, MW2, MW4. Okay. You save, download. Okay, close. Okay, monitor. Okay, go down. Okay, just key values here. Okay, just leave it 1000 Okay. Okay, you go offline. No, don't reset. Go offline. Now what I want to do, you power off the PLC. First one. Okay, off it. Okay, on back. We see whether the value is still there or not. The memory and also the DB values. This DB value and the memory. Okay. Now you monitor. Okay, whatever. For this one, because both the value go off. Because you power off, right?
Yeah.
Okay. Now we try to key in for again here.
But this one remain.
And because this one is from the program one. We didn't delete. It's a logic one.
Okay.
It's a constant one. This one is just now we deleted. Right. Okay, the value keep. Okay. Now what we do? We click again here. Key again. Okay. Then you go to DB2. You key in timer in. Okay, here. You put T hashtag 10 seconds. 10 S. Okay, enter. So you need to load all values. Okay. Okay. So even though this one is like this, no problem. Okay, I already loaded up. You go back to the main. You see the value. Okay, now loaded up. Okay, now. Okay, now we try again. Go offline, power off, and see whether the value go off or still there. Okay, value. I think now this one will be still there. This one also for the both off already? No, that one still have the value. Okay? Yeah, because it's take the because you already save the value in the DB, but modify the value in the DB, right? So the DB will give the value. Okay.
Because why here 10 seconds after 0?
No, because it means the DB is 10 seconds inside the DB. You see, you try to on is whether timer is there or not. Or maybe I need to download this. Okay, let me check. Modify to what? Play here. Okay. Then I think you need to download this. You open again. There's no one. Which one you click? You click this one, right?
No, I click this one.
Okay, you click this here. You click here. Okay. Why cannot? Load start value as actual value. Okay. Click this. This one, right?
Yeah.
Now you download lah. Yes. Okay, you go back to the main and see is the value is there. Monitor. Right. Go back to the DB. What? Okay, monitor first. Okay, because the value is not go in. Okay, it's supposed to go in here. You click this. Yes. Okay, now only the value goes. Okay. Go to main. Okay, you key value here. Okay, you do the memory reset. I also forget it. Okay. Yes. Okay. Allow name stop. Okay, you put a stop. Wait. You monitor again. Okay, now you reset, memory reset. No, now because it's a stop mode, that's why it looks like this. Okay. Okay. Yes. Okay, once this one done, you just run it up. Then you see whether I need to again put it out or not. Okay, go down.
So that means all those TON, CPU, all those if we don't use data block, memory reset is we need to set everything again.
Yes. That's why the global DB also same lah. The global DB, right? Just now we wanted to add, right, the DB. Same thing. So let's say the timer run, timer stop, all that yesterday, right? We use MD, right? So instead of using MD, we can use DB. So if you load the value, just now retain, you must use the retain lah. So if you can retain the value, so if power off and on also the value will be there. So if you reset also the value will be there. The set points lah. That's why set point they use the DB.
So I don't really have to use FB, I can just use DB if I want to create all this. Like I want to retain value, like for counter or whatever. So I create DB.
You can just DB, can, no problem.
DB and I call it into my FC.
Yes,
And then put the name.
yes.
Yeah.
But function block, if we want to use, if you have something similar system, then I can use function blocks like this. So normally we don't use so you go up, we have an FC, right? We have an FC, right? Okay. So normally only function block we do like this. Okay. FC we only normally for only one. Okay, why like this? Because okay, let's say I have two conveyors, okay. So this one conveyor 1, conveyor 2. Okay. If I want to do conveyor 1, what is the data? I just go to the DB, I can get all the conveyor 1 data. So if I want to know conveyor 2 data, whether it's alarm on, because normally not small like this, right? Or so many functions inside. Then I can see what is the motor speed value, what is the alarm, everything. So you want to take data easier, just go to the DB, get all the data.
Okay, FB is
Function block lah, that's the thing. You must use function block, then only you can get the DB.
oh. But you can also create separate DB.
Separate DB, yes, can.
But function block is so that your internal tagging and repeatability is
No, if a function block is something like you create one block, then multiple times you can use.
multiple times.
Ah,
This is
let's say like you have 5 conveyors. So no need to do like this 5 times. You do only one, then the block you go to main. Then this block 5 times you can call. Go up. This block 5 times you can call. The same thing this one also can do, right?
yeah.
Only different is if this one okay, now if I ask you which one is the rough one, so you need to see here the names, right?
Yeah.
But here, because since they have a DB, so you can easily differentiate. Number 1. Number 2, if you want to take some data from the particular, want to see some data, then I can straight away directly take from this particular DB.
Okay.
Okay?
Okay, and this one cannot.
This one don't have DB. But if you want to do, you can use a global DB to do that also can. Okay? Now, for example, if you want to use a SCADA, want to take some data. Okay, so if for this PLC, like one block, 1 DB is I can use for this conveyors. 1 DB I can use for this conveyors. So that is the advantage.
But for this one cannot. You need to call one by one.
Call one by one.
Or like I 0.2, 0.3
Yes.
and then
For FC,
Yeah.
you can take
internal
values.
use.
Can.
But it wouldn't retain lah.
It won't retain lah. That's the thing.
Also for FC, you internal tag or you tag from
The same thing, whatever we do in the FB, right? The same thing we can do in the FC also.
It's just who can retain the
Yes.
So if that's the case, I don't have to use DB lah. I just open FB if I want to do anything.
Yeah.
Yeah. So everything just FB. Because I'm confused. Like when there's so many, I'm confused.
Blocks.
Yeah, I'm quite confused. Like hard to remember. So might as well just use FC FB. That's it. When I return value FB.
Yeah.
Yeah.
Yeah, because if you use FB, already the DB come together. Right?
Yeah.
Yes.
Oh.
That's the thing. So it's very simple. So if you ask me like which one I will use, okay. If anything, number one, if I want to retain value, I will use function block. If I have something that repeating with the values, I want to get the values. Repeating and I want a value, function block. If it's just repeating only, the value is not important. I can use FC. Okay, because it's repeating but value is not important. I don't want to keep the value and use FC. Then I want to create like only one program. I can use FC.
Yeah.
Box also I just remove it from the back. I have to use. This one also I remove from the side. But this one is for the, this one is the holder.
This one if you want to connect to it.
I think, but you're not using this, right?
Mm.
So this one I put it inside. What is cable like?
No, and then the connector.
Oh. This CD.
Yes.
I just put it on top.
Mm.
Then later if all okay means. This one also I haven't seen. This haven't replied anything also. I think it's in overseas. Their laptop. That one I think need to install Unity Pro. Unity Pro and try. Let me test first lah with the virtual machine.
So things like this TON valve controller, this what do we call this? Function block.
Which one?
Like things like this. What do we
FC.
call? Function. It's just function. No
It's a code block.
code block.
Yes. Like this we do, right? We call it as a code block. because in FC, if I choose out, right, I only can use as a coil only. You can use as a normally open or normally close.
It means cannot latch.
Can latch.
Oh.
The latching won't work.
Is there a reason or this is just how it's programmed?
I'm not sure because before this, in SIMATIC manager can work.
Okay.
When they upgrade to TI portal can work.
Oh.
So they do that.
Okay.
I also don't know what's the reason. Because when I first tried, I normal latch, then I try to run, cannot latch, down,
Yeah.
cannot on. Then I try, cannot. Then I try this method, then can go. I mean, in up, then can go. Okay.
Yeah.
Now what you do? You see the DB, the global DB for HMI.
Okay.
So what you do for that, you open your mixer project. You open your mixer project, then we connect this HMI to your project. This HMI.
Okay. So the add new device.
Wait, first we go to the mixer project. Is it mixer project? Okay, you open the mixer project first. Go to program block, main OB. Okay, start, stop, all this, right? Okay. So yesterday we did HMI for the conveyor.
Yeah.
So what we do? Start HMI, stop HMI, timer, all that we create, right? Using memory. Now we want to use connect this first. L plus is positive, right?
Yeah.
This is L. So L is positive, you connect to here, and 0 you connect here.
Actually, if the body is can.
Balik damage.
Oh.
Live, normally live neutral or sometimes the balik kan. But not all lah. Some they will just like they will mention that. Okay. Good. Alright. Okay. Now, first we need to use a switch. Because why? The laptop want to connect to this and also this, right? And these two also need to connect it. So I need to use Ethernet cable. So this cable from the laptop and connect here. This is George's normal switch here. Switch. Ethernet switch. Network switch. A normal modem also can use. Okay, then from here go to the PLC one. And then it's going to put HMI. Okay. One.
The laptop link okay.
No, I attach it. They don't have Dell. Then this one.
That was done what I shared to you. 75. Yeah. The two link, the first one is the Lazada one, the other two is Shopee one. You can check the Shopee one. Oh, you need that.
No, not for me.
Oh.
Consider it.
You want to really lose that one.
Yeah, office work.
128 GB SSD.
120 or 2, but his budget is 1000 lah, below 1000 and he could spec.
The one is way below that. So,
Because you want to use for this one.
you can grab that.
Excel sheet. Normally he will use Excel.
Excel sheet 5th generation should do.
But he don't want to hang lah because now he's working in Singapore.
Oh.
Normally you do the all the shift works, all that. So you normally mostly using Excel, PDF only.
For Sarawak, the laptop price, I gave ready.
Yeah, I check.
And just let me check the training cable. The details okay. PID.
Yeah.
Both also same lah, agak-agak lah. Silap. And then I think maybe start first by sending quotation for the laptop and for the training. Then just inform him that the training kit you will send me the quotation later on.
Yeah.
That one will take time. For remote online training.
Okay. Now, remember yesterday we do like start HMI, stop HMI, yeah? Now what we do, we use global DB.
Sorry, global.
Global DB as a memory. So we can use memory, instead of using memory, we can use global DB. Okay. Go to add new block. use a data block. Okay, you put name HMI. Okay, yeah.
But before we continue, just to clarify, like just now we discussed, can use FD and all. So also can use FD for this, what we're doing now.
For this, no need.
No need.
No, what I'm doing here.
Yeah.
No need. No.
Cannot.
And no, cannot, because earlier one we use FB, okay, because we want to create a code block, because we have a similar process, so we want to only create one block, then we can use multiple times. So FC and FB both can do that, but we choose FB because FB can save values, can save data lah. Where it can save in a DB, right? That DB we call instance DB. Means that DB only for the function block. You cannot edit or cannot modify the DB. Okay? This global DB is like similar to your PLC tag. Okay, similar to your PLC tag means it's like similar to your memory only. Only advantage is this DB can save, can export. For example, now I'm using this HMI, right? For this one, I cannot use memory to do the display. I must use the DB. So what I do, whatever I want to for this particular HMI, whatever I want to show in the HMI, I list down. Then I create like an export lah. I need to export, then I need to import in this software, then I can use that.
FB cannot import.
FB no, FB cannot.
Cannot import. Okay. So all the functions.
FB actually can import export, but I can use import export and use for another TI portal can, for another project can. What I'm talking here is I'm exporting the data, so I can use for others. Like HMI, like SCADA, all can use the data.
Okay, so basically for HMI, FB cannot be imported to HMI.
No.
Okay.
FB and FC is a programming blocks. Okay, programming blocks. This global DB, this is global DB. This global DB is like a memory, like a tagging only, like a tag. It's no, there's no programming. It's just a tag. So I can import and export the tag.
Just data.
Just data only. Okay. You see, there's two data. There's a two type of DB. Okay. FC, FB, you clear, right? FC, FB is a programming block.
Yeah.
Okay. So means that you can create programs. Okay. So FC, FB are programming blocks lah, right?
Yeah.
Okay. Actually, FC is a code block, right? Code block or subroutine. Means you can use as a programming block or as a subroutine also can use. Okay. FB is code block only. Code block where it save the data. Save data in DB. That's all. Okay. DB got two types. One is instance, one is global. Instance is store data from FB or TI portal FB. Okay, TI portal FB means okay, what is this? Is actually your timer, counter, and some other blocks. It's a function block type. That's why whenever you take the counter, okay, DB. Whenever you take timer, it's a DB, right? Now, for that, it's a we call instant DB. Why? It's only store data from your function block. Okay. Global DB is similar to memory. Similar to memory, but what we can do, it can save data. That's all.
Similar to memory means
Similar to M0.0, M0. Similar, the same concept only.
so you can use data block as like a coil.
Yes. Can. It's the same thing. Only advantage we can save data or actually not save or retain lah. They call retain data. That's all. Okay. Yes. Okay.
No. Wait, there was a question just now. Oh, so FD's purpose is, you know, the repeatability of instance. Yeah.
Yes.
But why can't I just create instance DB and then every time I just pull into the main, also repeated, you know?
Okay, you create instance DB. Okay.
Yeah, and then every time in my main or I need to use this data or something, I just pull. Every time I just pull the name. It's also
You cannot create instance DB without a function block.
Oh.
Ah.
Oh, so this one is only for global.
Global DB.
Oh, okay.
This is called global DB.
Okay.
Because you see, you just click add new device. So you click here. Okay. So all these are instance DB. So it means this instance DB is for the counter. Down and I think these some counters lah. U counter, US counter, okay. I think it's a unsigned counter, double, all that lah, okay. Then this one is some other blocks, you know. Okay. So all these blocks are using this DB, okay, because this program don't have function block, so that's why no function block here. So okay, for example, you key IC timer. Okay, so just name it as a timer DB. Timer DB. Okay. See, this timer DB, right? Can you see? Already have some data. It means this DB, you go to main, you double click here. Just double click. Okay, click here. Only here you can use this DB. Only for this timer also only I can use. This is dedicated for the timer. So later, for example, you already have function block. Then you can create multiple DB. Then every time like you say, use function block, okay, put this DB. Use function block, put this DB. Can. But not necessarily, because every time you take a function block, automatically will create a DB.
Okay. So this one is just more steps.
Yeah, more steps are, but why we want to do manually instead of whenever you take it's automatically dry, right? Okay. You delete this DB. Yes. Okay. Now what we do? Okay. Go to this DB. So this is global, nothing inside. Now I want to key in, okay. What I want to show in the HMI, start, stop. Okay. Then timer VA in, timer VA out, timer mix in, timer mix out. Okay. All the timer change to time. Data types, yeah. With one change, then just drag it down. Okay. Now, this DB, you write it here. No, can I go to me? Okay. Now below this part you add.
Below start.
Okay, now you open. Okay. You put it here. You choose the HMI. Start. Yes. So instead of using memory, I can use like this. Okay?
Wait, can I see?
You mean the other division?
Yeah, I just want to see. Oh. So when you click into HMI, what are all these other things?
These other things is your global. I mean your tax. The PLC
PLC side.
Only these are the from the
Just now.
the DB. The blue color.
Okay.
Okay. You see now, this one don't have address. Can you see?
Yeah.
It's supposed to have address. Okay, what is that? How is the addressing? Okay, you minimize. So this addressing also important. Okay, go to but yeah. Go up, go up, go up, go up. Okay, here the DB. Okay, you see, DB1 means the block number. Then DBX 0.0. X means the bit boolean. Same thing. DB1, DBB byte 0, DBW0, DBD0. Okay? So this using the same concept only. Okay. You minimize. So if you want to get that data, I mean the numbers, okay, actually if you are using Siemens HMI, that number is not important. That address, particular address is not important. Okay. Why? Because later on you can add the HMI, then from the DB you can select. Remember, okay, you put press set bit, you need to select the tag, right? Same thing. Instead of choosing tag, you can choose the DB. Okay?
Okay.
But if you're using other HMIs, right, then you need to get the address. You need to have the address. Okay? Good? Okay. Now, so how to get the address? Okay, you write in DB for properties, optimize block access. So this one I uncheck lah. Okay, so means anybody can access to this DB. If I optimize only this within this TIA portal only I can use. Even this HMI also can use, because that HMI using WinCC flexible, another software. Correct? So that software, if I put a button, I need to put the DB. What DB? So DB. So this one is DB4, right? So it become DB4.dbx 0.0. But since in this HMI you want to add is inside this TI portal, then this one no problem. I can optimize, no problem, because it's within this TI portal. Okay? Okay.
So
Most of the time it just uncheck lah. Most of the time.
uncheck so that other HMI also can use.
Other HMI. Why? Because once I uncheck, I will get the address. So other HMI can use the address to communicate. So what you do, you need to right click the DB, the DB4, the DB4, the block,
The block.
yes, compile. Okay, now you get the address. Okay.
So I don't need to type the address in the top.
Yes.
But for other HMI,
So if other HMI, I need to type the address.
okay.
Okay, for example,
So
because
I
one,
can just compile and you auto rotate.
yeah, I will show you one. Okay, we just add one in the we just say, okay, we go to add new devices, HMI, okay, SIMATIC, basic panel, 4-inch, the first one, okay, wait, the first part number, just click once enough, 15.15, yeah, 15.1, that is HMI, okay, okay. Very difficult to take out this one without damaging the sticker. Yeah, just browse. No. Browse first, the PLC. Choose the PLC first. Okay.
Oh, bro.
Choose the PLC, then finish that. Okay, I will show you one example, but I'm not sure this laptop what HMI software. EcoStructure and big designer. Okay. Now you take one button and put it here. Okay. Go to the button property. Okay. Go to press. Add function. Set bit. Earlier, okay, he was choosing from the PLC tab, right? Now you need to choose from the DB. Okay, program block, DB4. Okay, got it?
Yes.
Okay, now we just save this one. Okay, just minimize this.
This one also.
No, the minimize the entire TI program. You go to NB design. This Omron HMI lah. I just want to show you. I'm not sorry for so forget. This one can use which one? Is this one delete?
The whole thing.
No, just this one delete.
This one.
Just delete. Yes. Okay, go to PT. No, PLC. Look for Siemens. You double click. 201 station particular key. Connector. Ethernet. Yeah.
Yeah.
I just put it there. Okay. Add PLC. Okay, here. Okay. Okay. Okay, go to HMI. This HMI. Okay, this is the one something. Okay. You double click this start button. Okay, this one right address, choose PLC. Right HMI. Close. I just forget. Okay, motor. Click here. Click here. PLC this one. PLC number or something wrong. Okay, normally here, you click here. Here will come out the DB. So what I do for this motor, right? This picture. Yes, right, okay. So after I do a proper settings, so here will come out the DB. So I need to choose DB for DBX 0.0. Something like this.
Oh, it will come out. Yeah.
Here. Okay. So if I'm using other HMI, I need to uncheck the optimize. If I'm using within the TI portal, I no problem. Because just now how we do, we go and select the DB. That's all. Okay? I might just close this one. I don't know why this one is not working. No, it can work because earlier got some projects, that's why. Okay, now we go back. Go back to main. So now what you do? So here start, here must stop, right? Okay, wait a minute, I show you this way down. Okay, go down. Then this timer need to change. To use the DB just now we created. Okay, go down. Here also need to stop. Wherever the stop, you need to add the stop.
Okay.
All the place. Then the root screen. In the screen, you do this program. Simple one. That is the start, stop. Okay. For start, stop, we choose from where? DB, right?
Yes.
For mixer, we choose from the normal PLC tags. Because mixer all is a PLC tag one. Q0.2, Q0.3. Then just like normal. Only this one from the DB. And also your timer. For valve in, timer in, timer out, right? Then for mixer also, timer in, timer out. So all these from the DB. So this is your DB4, DBX0. But no need to choose lah, just write it down here. DB4, DBX0.1. What would be this DB? What do you think? The number. DB4, right?
Yeah.
And this is a double word, right?
Oh.
So DBD, what number? What do you think?
Yeah. Double word. 2.
2. Yes. Why 1 cannot? Actually 1 can. Because we are just using 0 only, but automatically it becomes 2. You go inside TI portal, you go to the DB. You can see the number here is there. Can you see? 0.0, 0.1 automatically become 2. Why didn't go for 1? So that's how the software also works.
Oh.
So it will just skip. So all even numbers. So this is DB2, this is DB4, DBD6, DP. So, but you see, you no need to worry about these numbers, right?
Yeah.
You just create the name, then just use it in the program. So, what is the advantage of this instead of using memory? Okay. Number one, like we say lah, memory means this one can save data lah. Okay, number one. Number two, I can arrange the DP. It means okay, for this HMI, right? I use DP4. Later, I want to share some data to SCADA or something like I create another DB for that. So then let's say I want to do some calculation. I can use memory also can. Or I can use another DB for that. Means DB I can arrange properly. If memory means I cannot arrange. I just need to know. I need to arrange myself. Like example, from memory 0 until 50, I want to use Boolean. From 50 to 100, I want to use for HMI. Manually I arrange. This one is block by block I can arrange. Okay? Okay. Try it. Okay, you do this. You finish the program first, then you can go and check. Go to question.
only the name right you ask me. I mean the addressing.
Okay. The HMI kan not yet.
No, can have the HMI.
Go to properties first. This one. Yeah. General. Want to change the text. Or use later change to 2-digit now.
Okay.
Because I want to show you how to change to seconds. Okay. The outputs.
Yeah. pump also.
Oh, for pump also. Oh, okay, okay. But you haven't created anything?
I created it.
The DB created it?
Yeah.
Ah, okay. He left the guy yesterday.
What?
He left the.
He's laptop charger. Oh. start searching. The line is on.
Okay, so you can wait. Okay, use scanning. Where is this scanning? Okay, now you select the Canada.
Yeah, okay. Problem.
No. You select the HMI. Canada. Okay, no.
Address also see what I can try again. Yeah. Still waiting. Okay.
Sorry, the temperature transducer, the one include which one? The temperature transducer. These two, right?
RTD sensor converter.
Or these two, right?
These two is the temperature.
The transducer.
Same, transmitter, transmitter same.
Oh, okay.
Why? Okay, never. Close.
It's waiting. Flash
Oh,
cancel.
power.
This one.
This one. This power. The power supply. Hello. Huh? Yeah, I'm doing training. The data I'm doing training. Disconnect this.
From Malaysia.
Yeah. Power is good. Because the M is 1.5 M only. Should be enough, but I'm not sure. Because there's no blinking, right? First time I see this blinking. want both? So go to setting, transfer is enabled, network interface. This is the IP address of the PLC lah. Same thing we do also. Actually got inside of the program. Some program start on auto, but it won't work because not same, right? Now we go up. Go up. Okay, before that, because we do this all 2 digit, right? Okay,
Yeah.
we go down. Where we need to do settings, go to HMI tag. Okay. So we understand that for PLC, the value must be 10,000, right?
Yeah.
Okay, because so for PLC, the value must be 10,000. So in the HMI, when we key 10,000, the value transfer here to 10,000, then it can automatically convert to 10 seconds. So understand? Like yesterday we did that. Now what we do, I want to key 10, but I want to make it 10,000. Because in the PLC can 10 seconds. Why? Because this one in decimal, this one in time. Okay? So now for these settings we do. So we go to HMI tag. Okay, so it will show all the tag that we are using here lah. Okay, you click on the timer, the first timer here. Properties, linear scaling. Yes, linear scaling here. Okay, you need to choose. So HMI 10, PLC become 10,000. HMI 10. The end value here, end value. Yes, 10. The PLC is 10,000. Even you can put 1,000, 5,000 or something. So what we are doing here, linear scaling, you know, right? What we are doing here, we are doing this. That is, we key 0 to 10, the value becomes 0 to 10,000. So it can be any value, are not limited to here. It can be any value like. So we need to do for all.
Okay.
do for all.
All the time also. All the time also. Yeah, that's okay then. Save.
Now you select the HMI.
This one.
Yeah. Download. Okay, start search. Okay, you click here.
Which one?
Wait, let it. Click that. Okay, choose the PNI. Because direct means we direct go to the HMI lah. PNIE means the communication using this one.
This.
Yes. Okay. Choose PNIE. Try first. Okay. Start search. Because if anything problem with the program or something, when I download that time only it can now look. Yeah.
Yeah, still good.
Close this cancel. Now you're trying to direct transfer. Try direct transfer. Now because I'm not using that one, download. That one delete that one.
but it happened once just now. Just now, also like this when I tried to download, and then I went to compile, then it can compile, and then I click hardware and software changes.
But that one for PLC, right?
Yeah.
No. No, it's not for me because it's not me. If no, it's always me. Oh, so it's two, right?
Yeah.
Your laptop also two. Cannot communicate, cannot
So this need to be three. This is one. This is
one,
two.
two. Just put 10. That's the reason. That's why I say, why? Because last week, when I used a few weeks back, I used all of it. Coming back here. So because both same IP address, so it shows conflict. Okay, now you try to look.
Overwrite everything.
Yes. Now we go to your PLC program. Go online with the PLC. What is this one?
Why?
Hashtag means communication problem lah. Okay, why? Because we haven't downloaded the program.
Oh, it's not running, you know.
So what happened? This one all DB right?
Mm-hmm.
Inside here they don't have the DB. That's why. Yeah, okay.
Oh, just now I download the HMI.
Yeah.
Download the PLC.
Yes. Finish. Oh, okay. You go to PLC, you go offline. Okay, right click PLC, go to properties. Go down. This and here. Go down. Then one more for setting. There's on. Only allow yes. Okay. Right click, download hardware configuration. Right click the PLC. Download hardware configuration. Download hardware configuration.
So the secure connection thing, the one obviously
Always need to answer.
you go to troubleshooting also like that.
No, this one because this one all latest CPUs 4.6 like that. Because of that problem. But normally I troubleshoot all old systems, right?
Mm-hmm.
Because all this one all is recently like last 2 years updates. This one.
Okay.
For this IS, this PLC is new, right? I off because I want to connect to the HMI. Now you see. Okay, first timer reading. Okay, I put 5. So you see I put 5 seconds. You right click the number there.
This number.
Right click. No, you select and cannot have. Okay, can second. You select the name. No, just select. Right click. Display format. Tag decimal. It's 5,000. So here you key 5. The PLC become 5,000. So it's a 5 second. That's why we do this setting. So you can put any number because you just want to show this is the gradient. Okay?
1 to 1000.
1 to 1000 can, 5 to 5000 can. And pump also I put 5. Mixer also I put 5. Okay, go down. Yes. Okay. Now I start. 1 here. You can see this and on running and high level and so on. It's the time also running. Then high level on timer running, then running pump on.
Actually, the out is what?
Not out display.
This
The timer counting lah. It shows the timer value.
for this setting and then this.
This is setting, this is display.
Okay.
Okay? So now you know how to download it. Actually, you know the day we do this simple start stop button, but we open in our laptop, right? Same thing only. Only different is need to download it. That's all. That's why I have only one this one.
Okay. But
Because I just want to show how to download only right now. Because this one is very expensive. You know how much this one? 3,500.
HMI.
This HMI.
HMI only.
Yeah, this one only.
More
Expensive than PLC.
PLC.
That's why this one they ask for 10 inch. I use WinTech. It's around 12,000. It's a China brand, but it's okay because they just want to know, want to see the values of it, not a big controls. Because 10-inch Siemens one, I think it's around 15 to 17,000.
What are they studying? Like what course is that?
No, this one I'm not sure. For lecturers they use this. Okay, so what happened is they do some research for that only. So they have like a brick. I'm not sure. They have like a brick. They want to supply methane and CO2 gas. Okay, then they want to heat the plate. I mean like a chamber like this. They want to heat the plate, but not the temperature is not high. Temperature maximum like a 60 only. They want to maintain 60. So when maintain 60, then when the CO2 decrease, they want to add more CO2. That's all. So actually they currently have a small like this. It's already been like a machine they already have. Now what they want to do, they want to create the same thing in a bigger one, using PLC, HMI, using the sensors on it. Now they like a fridge only, a small one. It's already everything is there. They have a small display. I'm not sure whether they're using PLC is like some microcontrollers, like microcontroller, like a Raspberry Pi or that. So I'm not sure which one they're using. Those a small one, they have this space only. A small one, they have this much space to put all the plates. So not enough. So now they do like very big chamber. So
Last time they also asked you to make that one.
chamber.
No, the small one.
No, it's not. It's like ready-made system.
Oh, okay.
It's like a ready-made system they buy. From China, if you order one machine, they will create everything like something like that. So like ready-made system. But they want to do same thing. This one exactly similar thing. With a bigger chamber everything. So my part is I just do the panel, program everything.
So you the budget and then you choose lah. What?
Yeah, initially they asked me to use Raspberry Pi. Raspberry Pi is like a computer also. You know, have you heard about Raspberry Pi? Yeah. Then display. Then I say I'm not familiar with Raspberry Pi, and your sensors all you're using is like industrial sensors. I want to use Raspberry Pi, and I need to have a board, control board where all the input connect here. Then from there only I send the signal to Raspberry Pi, or I need to buy an Arduino, right? And I say I better Raspberry Pi and the Arduino all the board include. It's around 1,000 plus, right?
How expensive?
Which one?
Raspberry Pi Arduino.
Raspberry Pi, I mean that one is around 400, 500 only. Then I need to create a special board and an Arduino, because Raspberry Pi is like a computer. How you want to connect the input there? Not enough inputs. So I need to use an Arduino, extend the input. And I say why better use PLC. Then I say I'm not familiar with Raspberry Pi or that. I'm familiar with PLC. If you want, I can use PLC. They say okay, use PLC.
Oh, but more expensive, a bit more.
A bit just nice. From their budget, I see this one is around 25%. That's all.
But more user friendly, troubleshoot also easier.
This one is
Yeah.
anytime want to add, can add.
Actually, don't need to know, right? Like Raspberry Pi Arduino.
No need. If you're working in industry, don't need a Raspberry Pi.
Who only use it?
Normally, who use Raspberry Pi is okay. First, Raspberry Pi and this one it's like project. You want to do a project,
Low budget.
low budget project, or okay, let's say the company needs something, then you want to create. You see PLC expensive, so you want to do a prototype using that, can. Then use same process using PLC. Okay, and Raspberry Pi is, if you want to take the PLC data and send to cloud, send to your phone in cheaper way, can use Raspberry Pi. If industrial standard, if a proper way means you need to have a laptop, then the PLC share in the laptop you need to install a OPC software. Okay, OPC, that's what next week I'm teaching lah. So OPC software, that software will take whatever data from the PLC, extract, Then wherever I want to send, I can send. Okay, that is number one. Then if I use laptop, of course, like expensive. Then I need to buy the OPC software, all that. If I low budget but still want to do this thing, then I can use it. The last time I went to a company, they asked me to troubleshoot. What they do is Siemens S7-1200 PLC. Then they sending this data to their main server. So 200 cannot directly send because don't have Ethernet also. What they do, 200 connected to a Delta HMI. From the Delta HMI, they take data to the Raspberry Pi. From the Raspberry Pi, they send data to the server.
If they don't want to use Raspberry Pi, they need to change PLC.
Yes. Change PLC or must have a computer, the system there. So the PLC need to connect to the computer first.
Also expensive lah.
Yeah, of course you need PC one. PC and the software. Raspberry Pi no. Raspberry Pi is already like a built-in software with a small PC. They come with like a small LCD, right? Actually I wanted to try, but then I see, it's around 400, 500. So to buy and test, I want to learn something. Then I think, why I want to buy?
Yeah.
And where I want to use?
It's not
It's not
for
like for industrial practice lah. Then even Arduino also last time I wanted to buy and try. Then I think for what I want to use that. Not using for PLC.
Those things use coding.
Coding.
C++.
Computer programming, yeah. I mean computer programming language like C, C++, all that can support. Even Python also can support in Raspberry Pi. That one can use that for smaller systems. Even companies with smaller systems use PLC because why? Can tahan. PLC all can tahan. Heat, all that. Even let's say Sean told me, one of the systems, the outside environment is very hot. Around, if you measure around 50 plus temperature. So how to protect the PLC? Because in the PLC, you see, normally they put the temperature. How much? Yeah, so like 60 lah.
But those Arduino, Raspberry Pi, very fragile.
Yeah.
Okay.
Like want to do like a house, home automation. That one all very good Raspberry Pi you can use.
Yeah, okay. Look into it.
Yeah. You want to do like home automation, you want to control your house, all these lamps, all that. But for that also they already have all these on the home automation devices already. Okay, go for break. After the break, come and learn analog for break.
Okay, can.
So, you create new project. Day 4 analog. So what I want to do, I want to add this. And this card, out analog output card. Okay, because check what any analog input here. Analog output on right. So I can add this one also okay, here also okay. So this one
here,
the small one is okay. Because I'm adding here. I want to take out this. Push down and okay, so you add this module. Analog output module. Then the part number here it is. Analog output 4 IO EQ 4 yeah. I think the second one. 4 HD32. You see here?
AQ4. But then
Okay, can?
Yeah.
Okay. What is the address? So your AI address is 64 and 67, right? Analog input address, huh? Analog output? Make it bigger some more. Put it some more. Your output is 96, 98, 100, 100. Okay. First, your machine, your company machine, you know what is analog?
Basically,
What is your idea of no idea?
no clue. I remember you said digital is 0 and 1.
Yes.
And analog is
Very.
Yeah, very.
Very. Just basic. Okay. So analog means value lah. So what is the analog? PLC can read what is the analog. Okay. You go to my slide. Okay, go down. Okay. Go up. So this one is you say digital lah. You see digital input on off. Go to the PLC 01. And from the PLC 01 become on off. Go to next. See here, analog input you can measure in voltage or ampere. Okay, this is example only. Actually got so many. So later you can see. Okay. So how it works? Okay. So let's say pressure transmitter you can see here. So it will measure 0 to 250 millibar, not megabar, millibar, and convert the value into 4 to 20 milliamp. So when it goes to the PLC, it becomes 4 to 20 milliamp. Okay. Same goes for this temp. This is a temperature transmitter. For temperature transmitter, you see it's measure negative 50 to 150 degree, and the output is 4 to 20 milliamp. Okay. So it measures the temperature probe. Okay, that give you a 4 to 20 milliamp. So it means any device that within this range can give you values is an analog input. Okay, so let's say for example, because for this project I have a lot of analog inputs. I need to measure methane gas. There's a sensor to measure. So that one is 0 until 2.5 volts only, can also. Okay, anything within the 0, from anything within 10 volt is analog, but must be range. It's not like positive. It's like 0 and 5 volt. It's to power up. Let's say for a lamp, you power up 0 or 5 volt. It means it's just on or off only. It's not a range. It must be a range, means from 0 until 2.5 or 0 until 10 volt. Okay. So then they have a pressure sensor. Pressure sensor I'm using for 20 milliamp. Then pressure sensor I'm using 0 to 10 volt pressure sensor. Then milliamp, for temperature I'm using for 20 milliamp. Then I have another one, humidity. Humidity of same. I have a humidity sensor also 0 to 10 volt. Okay, so how it works? you have a CPU, okay, then analog input line, okay, then you have a transmitter. So this transmitter I can connect, depend lah what type of transmitter lah, like pressure or temperature. For example, I put temperature. So this temperature, let's say, is 0 to 150 degrees Celsius. So this temperature, because why cannot direct connect? Okay, why? Because normally temperature sensor got two types, TC or RTD, thermocouple or RTD type. Thermocouple, if you measure, I have the sensors here. So this is thermocouple. Can you see? I have two wire thermocouple.
This is very
That's the temperature. This is the temperature program. Okay. This is the RTD type. RTD type will have three wires. Okay. Now can you see PT100 or PT100? Okay, why they call PT100? When temperature is 0, it will show 0 ohms. If the temperature is 30, it will show 130 ohms. In ohms, okay? Let's put it here. So, but others all, beside temperature, others all is already built-in transmitter like a temperature. Okay? This one is like a temperature transmitter is additional. Because you have a temperature probe, then because so this one is millivolt, this one is ohm. Okay. My analog is what? Only can measure these two, right? So that's why I need a transmitter to convert these values 0 to 10 volt or 4 to 20 milli, because these two are common. Then my analog input card, because you need to convert this value to digital value, a value, because PLC cannot read these numbers. So in the PLC you will get 0 to 27648. From where I get this number, you can get from the hardware manual, from the PLC manual. CPU manual, 1002 manual. And another thing good about Siemens, all the 300, 400, 1002, 1005, all the same number. So not do it. Only S7-1200 is different. 0 to 32,000. The 200. Okay. Now, okay. Only temperature have like a additional transmitter like this. Okay, others all is a built-in transmitter. Okay, if you see, if we think of logic, for example, I have a pressure transmitter to measure a pressure inside a, let's say it's like a bottle, for example, closed bottle. I want to know what is the pressure. So what I do, I put a hole, I put a pressure transmitter there. Okay, okay. How the transmitter measure the pressure? If you think of logic, right? Sure, inside the transmitter there will be a resistance to measure the, like a small changes in resistance. Correct? Okay. So what happened? That resistance convert into these values. That's why they call transmitters or transducer. For example, like humidity. Sorry, what? Humidity. Okay, so how the sensor can measure humidity and can send these numbers. Right. So sure, inside there is something to read the humidity. Right. So means something there is a small difference in the resistance that they, of course they have a PCB board, go through all the electronic components that can become like a value 0 to 20, 0 to 10 volt or 4 to 20 milliamp. Okay. And only for temperature they have a temperature module. You go to TI portal, go to AI, this AI. Okay, can you see? RTD thermocouple. Right. So in this, if you're using this special card, you can directly connect the sensor. You don't need the transmitter.
The AI is connected in the middle.
No, this one is at the side only.
Okay.
Because only the board only in the middle.
Oh.
You can add in the side. If you want to add, can add one. Example, you add one, then later can delete. Here. Yeah. See, like this. Right click, property. Okay, AI, analog inputs, channel 0. You see? So you need to choose PT100, Celsius, thermal resistor, measurement type, how 2 wire or 3 wire or 4 wire. Choose here. So you choose what? RTD, right? So must use thermal resistor 3 wire. Then the range resistor is what? Using PT100. So you see PT100, R100, all that. Okay. Then temperature scale. Okay. So it's Celsius. So what is the thing is, if I use this, for example, I use AI RTD. This is the CPU. Then straight away the RTD module. Okay. RTD module is a PT100 lah. PT100. Okay. What happens? Here you will straight away get the temperature. Depend on, because normally PT100 will be temperature will be, can measure from, if not mistaken, 0 to 100 or 200 or something like that. Okay, we will check. Okay. For example, means straight away you get a Celsius value. Okay?
In the CPU.
In the CPU, straight away you get a Celsius value. Okay? If I use this method in the CPU, I won't get the Celsius value. What I get is 150 Celsius, I will get this number. And first, later we see about this one. Only for temperature they have this special card. Other than temperature they don't have. Because like I said, only the temperature is separate. This is a temperature probe, this is a transmitter. Like two different things. If other than that, all is one transmitter. Pressure, what flow, everything is one transmitter. Okay? Now, so programmer, what you going to do? You can use this number to show in the HMI. Right? So you need to convert this number, your analog input, let's say analog input 1, 0 to 27648, convert to 0 to, depend on your sensor lah, right? Convert this. Okay? You can use y equal to mx plus c. Do the calculation lah, find the m. C, calculate Y. So you can do like this calculation lah. M equal to Y maximum minus Y minimum, X maximum minus X minimum. So to get the C, Y minimum minus M X minimum, you will get the C, you will get M, calculate this, you will get the value. Okay? Calculation lah, right?
Yeah.
Must use real, correct or not? Why real? Because Y divided X. So 150 divided this one, you will get a decimal numbers, so we use real. But all the PLC, they will have a block, special block for you, a scaling block. So you just key in the data, it can calculate for you. Okay, good. Okay. So that's what we want to do. So first, you take out this, you minimize this. No, okay. Delete this RTD. First, your AI address. So you, how many AI you have?
One.
Two.
So
AI 2 here. 2 analog input. Okay, this one here. Yes. Can see there is 0 analog. What is the address? I put AI 1 and 2.
yeah.
Okay, what is the address?
I 0.64.
No.
Wait.
I correct?
IW
Yes. IW
64.
64. So next one IW
65. 6.
W, right?
Yeah.
66. But here it shows 64 until 67, right? Because this one is 64 and 65.
Okay.
This one is 66 and 67, right? The byte number. So it's showing that you already used byte 64 until 67. So next available byte is 60. Okay, good, got it. Now analog output. A01, A02. So this one will be the last one. Your analog output. So what is the address?
QW2.
No.
Oh, this one.
Yes.
QW96.
Yes.
98.
96, QW98, and A03, A04, right?
Yeah.
QW100, QW100. Okay? Actually, the tagging, right? Normally, where we put the tag? PLC tag here, right? Actually, you can put the tag here itself, can also. I show you how to do that. Okay, you click on the PLC. Look at this PLC, right click properties. Properties. Go up. Okay, of course, our PLC got so many things. Okay. Go. Okay. Still do. No, IO text. Okay, let's see. So you can give a name straight away here also can.
Oh.
You don't need to go to my PLC tag, give the name. You try to give
This one also under PLC tag. After I key.
automatically, of course. No, not start. AI1, AI2. Then the below one, let's say that I put start, but we're not going to use. Just showing you. Okay, go down. Output you have. Output also should have. Okay. See? Output also there. Okay. Okay. Then for the analog output card, manually, another properties. So when you do projects like this also can. Here.
No.
No need to think Ini analog output A01. Okay, save. Okay, you right click here. Download hardware configuration. Now what we do, go to watch table. IW64. So we want to connect this. Oh, you got error. Okay, then what do you do? We go to online and diagnose here. Online and diagnostic. Go online. Go online. So it's going to show error, right? You see what is the error. Go to diagnostic. Diagnostic buffer. Click on supply voltage.
This one. Yeah.
Power off. Give voltage 24 volts. Connect this one. Okay, this one is an injector. Okay, so you can for training can use like for because if you want to use temperature sensor. Because I have a temperature transmitter, but it's a 420 milliamp. This one ours is new 10 volt only. Okay, so we can use this one injector. So what you do? 24 and 0. You see? 24 ground is 0 right? So you connect your 24 to 0. Okay, and this one ground go to the 2 amp because ground is 0 volt. The analog voltage go to the number 0. Okay. Then another one is then this one also must give life and L plus, right? Can you see 24 and M can share from there. If no got terminal, okay, you use. If don't have terminal, you share.
voltage to 0.
Yes.
And analog input to 1. Analog I, AI, analog current.
No, only current. What enough? What input enough?
Only the voltage.
Only the voltage. So later there's another input, right?
And
Now only you use input 0.
yes,
Input 1 is still there, right?
yes.
So that one later to tomorrow maybe we connect to the motor, the blue color motor.
Okay.
If no, what space?
What?
If no means you can tap from here also.
Oh, share.
Check and
It's too big.
wait. Refurbish it, buy from the time.
Oh.
Awesome. Because PLC I buy new. This one, what I do normally I use that one, the center one. So I have two lah. So sometimes I'm training for 8 packs, right? Only 2 like PLC got this. Other PLC don't have, so that's why I wanted to buy this one. But this one they have only new. 600 ringgit. This one, what? Second hand. 480. So I buy this one too.
If I go, can I find second hand product?
From there.
Yeah.
Yeah, sure. They will put it display. What PLC you want, everything there. So your company only have
Mitsubishi.
only a Mitsubishi, eh?
I put wrong. It's supposed to come. No.
Same.
Not here.
Yeah. Only Mitsubishi.
Yeah, they only use Mitsubishi.
Then why you learn Siemens? Oh, you learn yourself.
I learned already, I want to leave.
Oh.
And I chose Siemens because it's more popular. If I learn Mitsubishi, then I jump later, they won't use Mitsubishi. Yeah.
Right. If you know one PLC, the others one can know already.
Yeah, can pick up later.
Can pick up later, no problem. Just understand what PLC can do. So what this PLC can do, for example, you can program, you can add analog program, all that, right? Just do the same thing in other PLCs. Just need to know what software they're using, how to do the program, what is the address they use.
How to navigate through the software.
Yeah, that's all.
Yeah.
For example, this one, for input they use I, which they use X.
Oh, is it?
This one, the
X and Y. Yeah,
X and Y.
This one. But I leave, and I'm planning to leave my company because they are holding me. They want to give training.
Haha, that's our normal.
Already nearly 1 year since I give training. Then
Most of the companies.
yeah, I feel like wasting my time.
Yeah, lah, of course. If they don't want to send you, because you know what? HRDF, right? They can claim from HRDF, right?
Yeah, 100%.
It's actually your money.
How is it?
Okay, so how it works is, okay, so company need to pay, not, but I'm not sure every month or every year, some percentage lah, but as I know, it's 1% from your salary need to pay to HRDF.
Oh, really? One person. How?
I'm not sure how it works.
So it's not necessarily.
All total employees.
Oh, so everyone pay a certain amount. Of,
No. Everyone pay some percentage. I mean, some percentage lah, but all fixed percentage only.
yes, you cut from the salary everyone.
Not cut from salary. I think from this is a salary, so company pay based on your salary to the HRD or something like that.
Oh, they pay extra.
Yeah. So that is company money, you know.
Yeah.
So they need to claim. If they didn't claim, it will burn. Within 3 years, they didn't claim. When you go to 4th year, the first year money will burn.
Oh. And
So
they also have a budget and a fixed amount.
Yeah,
Like 1 year you can claim how much.
no, it's depend on how much you have in the levy.
Yeah. Oh, that's why the boss say low on budget. But I didn't believe him.
Because they will plan for other trainings.
Yeah.
Normally, engineering department very hard to get training.
Yeah. They
I-
give
I-
training to maintenance.
I've listened to so many participants and they say very hard to get training for engineering department. Other department very hard, like soft skill, time management training, all these kind of trainings. Even sometimes have you heard about internal trainings?
Yes.
That one also can claim from HRD.
Internal? But internal no cost.
It's under your some one of your employee will do the training, right?
Yeah.
Yes, that one also can claim under HRD.
Okay.
So what they do, they claim within the company.
But why engineering so hard to get? I don't know. By right, you know like what time management, all this go and learn online.
Even building, team building,
Those also got training.
that one also can claim.
Also need to pay. I mean also
Can claim.
nonsense those training.
Okay. Now you power on.
Actually, what other kind of skills are necessary for engineers? Like let's say after this I want to do a course.
If you want to
It can be anything, it doesn't have to be this PLC. It can be
yeah, that's what I say. Because you go into this, engineering side, maintenance side. You are mechanical, right? You don't have like electrical course.
do electrical.
Electrical training, because we also teach, but you can go for other like electrical training for non-electrical engineers. So it's not for electrical engineers because they know electrical training. So it's not for non-electrical engineers like 2 days training. They will teach you live, neutral, this one. So you get some certificate on that.
You guys have?
Yes. Yeah. 2 days, 2 days training, 2 days training. Then what type of training? I forget training last time. What I do last time, I go to LinkedIn, right? LinkedIn. Then okay, let's say what job are you looking for? What type of roles? For example, maintenance engineer. You just go for maintenance engineer, search for which company offer this one, and what are the job scope, what they are looking for. So you list down like a few companies, then you list okay, company A, company B. Then you see which one is similar. So which one they require most. Then you look for the cost. So last time that's what I did around 5 years back.
Like that.
So because when I see the last time when I want to go for PLC side, say minimum 1 year. Any PLC, not any PLC, like some company they say Mitsubishi and Omron, some company they say Siemens. Then after that, after 1 or 2 years, I check again, they say minimum 2 years. You need to know PLC, you need to know SCADA, you need to know HMI.
Which is everything here.
Yes. But minimum 2 years experience.
When they say you need to know, will they expect you to know how to wire and all that?
That's the thing. if you're going for programming only,
Which is this is it?
programming only, not necessarily you don't need to know the wire, but at least basic wiring, like this wiring in the end up. You know, the positive, negative, like neutral, input, output, that's enough, because you are not going to wire up because because for programmer, I just need to know whether input on or off, that's all. I don't care what type of input, what is the voltage. Same goes for output. My as programmer job is to turn on the output. So I don't care the output is going to a lamp, going to a relay. That's why when we do project, the project name we put motor. But are we actually turn on a motor? No, right? We are turn on a lamp. But if I take out the lamp, if I put a relay, then relay can control motor. So the program is still the same thing. So the programmer just need to know the concept, how the motor works, that's all. Okay. Then if you go to commissioning side, some company they do programming and commissioning. Then you need to know how to test the what, like whenever you connect and test, right, continuity test to check whether the positive from the power supply you go to the terminal block, from the terminal block go to some other places, right? So you need to check all the other places correct or not. Is it the positive and negative are short before a power? So all these things. So you are from Puchu?
No, Kota Kemuning.
Okay, sorry, Kota Kemuning. So you think around there lah?
No, anywhere as you can. As long as they pay well. My current company is very low paid. Even though they're a big company, 3,000 employees. Oh, but the pay is...
You're looking for like MNC or like the service providers, means like vendors?
I think I will be looking into service providers because not only the workload is very tough, right? As a vendor,
Yeah,
it's tougher, but then I think learn very fast.
Yeah, you can learn a lot of things.
Yeah.
You can learn a lot of things because if you go to a company, so they will give you these tasks. So you only do that task only. Other than that, you don't do anything. So if you go to like vendor companies, of course today they face this issue, tomorrow they face this issue. Because I know one company, check with them. Right? They do projects. Mostly they do projects lah. Projects all time. They use Siemens. This PLC all I buy from him only because he is a Siemens SI. So he get cheaper price. So when he sent to me also cheaper price also he sent to me. But he sent to others they are expensive. Normal price lah. He give me a cheaper price. Only he will add a little bit of money for him. Okay, because this one also I buy from him also. You know I buy this one how much? 5,400 something.
Sorry, what is that? Oh,
1,500. Because PLC include analog and
output. Is it?
analog input output. If the same I/O, if for this right, 16 input, 16 output. So I buy 10 input one, then I buy another 8 DI, 8 DO, so 8,002, 800, 2,000, 2,800, then analog card. The same I/O for that I buy, it's around 3,000 something. 35.
Oh, so still cheaper.
Still cheaper, of course, not cheaper. But this one can do a lot of things. Can do advanced programming. So that's the reason. Just now you was saying like I do something like with this one whenever you do something. Because what happened? The memory card. This one got memory card, right? So this one must use memory card then only can run. So I have one new memory card and one old memory card. The old memory card consists of that program. Okay, so what I did is I put to my memory card video, try to format, put here, cannot read. So what I did, take out, put to this, because the new card can work. My old card, because I format already, right? then I put inside here. I go to software, I because this one can read the memory card. Because this one is still new. No program inside, right? So I put inside here. I format to use this. Then now I put here. Now I can download. There's a way to do that. But all that, you know how I did? I just go, because whenever I download, got message. Then I go to Google and see. First initially I thought this one no need memory card. After I download, then only I don't need memory card.
Would it run out
Huh?
of memory? Run out of space? It's a memory card.
That's memory card.
Yeah, it will run out.
This, you mean the memory card crash?
Like use finish lah. Memory use finish.
Can.
How many GB?
This one 4 MB only.
4 MB.
4 MB now. For programming 4 MB now. 4 MB too much. Maximum can go up to 64 or 32 GB. But you cannot create 32 GB of program. Why not? So why 32 GB? Because in the memory card itself you can what save the software. TI portal you can save that. Some documentation you can save that. Same time the program also can be saved there. Then if you're doing data logging, yes, every 1 second you want to log the temperature reading. All that can do.
Okay. For those need like
Bigger one lah, bigger memory card. Now this memory card. Okay. Now what do you do? Try to go online again.
Still got this different level.
Why? Go to PLC tab. Because just download hardware only one just now. Right?
No problem. Oh.
No. Just now you download only the hardware, right? Hardware configuration.
I don't know.
Because just now we add the module, then we just download hardware configuration. We haven't downloaded the program.
Okay.
So, but even no program, right? No programming, right? No program inside, right?
So should download that?
No need to download.
Oh, I agree.
Why it shows different? Because the tagging. Yes.
Oh, this one?
The tagging lah. Okay. Just continue with your. Okay. So you go to watch table, you key in IW64. monitor. The spec.
This one.
Yeah.
Yeah.
Summary.
Yes.
What's the value again?
It's 700 something, fluctuating.
Okay, fluctuating, right? So not exactly 647, huh?
Yeah.
64. Okay, now. Okay, if okay, then you go back to OB1. Okay, close. You close this. Okay, now, so you don't need to do like this, right? Like I said, because they already have the block for the values. Okay. So what is the block? Is go to conversion operation. Can you see norm X? Okay, you take the norm X, put it here. Okay. Then beside that, put scale X. Yes. This is the one. Okay. Then, so norm X is convert. It will normalize the value. So means normalize the X axis, then scale the Y axis. Okay, it's not like input or output. It's the X axis, Y axis. Okay, just remember that. Okay. So your input is your X axis is what? Analog input, right? So must be integer. Okay. Then this one, click here. They have only two options, real or long real. So we use real. Then here is depend on what we choose here. Real. Then here will be your Y axis. So now is a temperature, right? So it depend on you whether the temperature you want like 50 degree or 50.5 degree.
So if I want 0.5 means decimal means.
So if you want decimal, then you need to use real. If you want just normal numbers, then just choose integer.
I'm going to use real.
Okay. Okay. Now, begin data. This one, right? Actually, this block, this block is something similar to FC type. Yeah, correct. Because no DB. Like a timer is like a FB type because got DB. That's a difference. Okay. So what is the value? the value is IW64. Okay, what is the minimum of IW64? 0 to 27,000.
Sorry, 0 to
0, no, 0, minimum is 0, maximum is 27,000.
The one need to remember is 276.
27648. Yes, need to remember. If you forget how to get, go to the, if you forget,
the
very
manual.
simple. The manual I have inside there. Yeah. You go next. Here. Or just go to Google S7-1200 analog manual. Sure you will get this one.
So for different PLC,
different values.
just Google.
Just Google. If you want to get a correct, if you want to confirm whether it's the Google one is, of course Google will be correct one. If you want to confirm, just download the manual, the hardware manual. Then look for, just search for analog values or something. Okay?
Okay. Let me get it. Okay. So the out is QW96.
Output only. They're not the output. Okay? Because it's not related. We want to convert this value to this value. Okay? Okay. So normalize means what happened? It will calculate this value, change into like a 0 to 1. But not 0 to 1, it's 0.0 until 1.0. Like a percentage like. Okay? So what we need to put in the memory? So put MD. So that minimum, okay, what is the minimum? Your output minimum is what? Your Y minimum.
Y minimum 0.
Okay, put 0.
IW66. Yes.
No, 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 no.
MD0.
Yes.
Oh. Okay.
Okay, then the output MD4. Okay, you rename that one to the MD0. You put norm X1. No, that MD4 is your temperature.
So I should put temperature.
Yes, temperature. Okay. Download address.
stabilize the data. Is it?
Not stabilize, is convert the data into 0 to 1. Like a percentage, like convert to percentage.
Okay.
Then that percentage you multiply with 150, you will get the value. Got it?
So maximum is 10 volts.
Yeah. So 0 to 10 volt. So if using for 20 million, it's for 20 million. Okay, then
Yeah.
we go to maximum 27.
Go to here.
Rotate. Maximum, what do you get? 27 what? Two seven six four five.
Yeah.
Right, maximum, right? So then you can calibrate lah. Calibrate means just change this value to 27645 or something.
Okay. If I go further,
Cannot.
this thing cannot go further. That's all.
Download again. now we want to see how to scale output.
Scale output.
Scale the output. Can I erase this?
Yeah.
Output also similar like this. Only difference is then the output is connected by that. So CPU send this value to analog output. Okay. Then my analog output will convert this value to this value. Will be connected to inverter. Then this one connected to a motor, pump. So output very simple. Output is anything that is motorized device, like a motor, pump, valve.
What does an inverter do?
That one control the motor speed.
Oh, it's just to control motor speed.
Yeah.
Is there anything else that an inverter does? No.
No, mostly it's control the speed of the motor lah. I mean control the frequency lah, the motor frequency. They call variable variable frequency drive. So VFD function is just to control motor speed, called VFD lah. But why they call inverters actually? You supply AC current, right? You supply AC current, it will convert into DC. Okay, so the DC can be variable. Okay, then the DC convert back to AC, go to the motor. That's why they call it inverter, because inverter is stand for AC to convert to DC. That's what normally called. Common name lah, but actually we call VFD or VSD also called variable speed drive or variable frequency drive. So normally they control speed and torque. Okay, because some motor is direct online, means it's just straight away run full. I say the motor you buy is 1500 RPM. Okay, that motor also, that's a normal motor only. You just directly can run. Connect power 230, depend lah, because normally motors can 230 415 or something. 230 delta or star connection, but you need to have both connection. Okay, just you give the power. Normally contactor control the motor, right? So you turn on the contactor, you run full under, let's say 1500 RPM, fully 1500 RPM. If in between the PLC and the motor you put a VFD, so your PLC send data to the VFD, VFD control the speed. So now VFD can control on off and also the speed. So how many hertz you want to run, how many RPM you want to run. So tomorrow we will be working on the motors lah. Okay? Okay, now our analog output mostly anything. So inverter control but motor. So motor, what type of motor? All type of motor, pump, blower, all rotating, right? So all type of that can control. Then like a valve, control valve. So let's say some valve is just open and close. Some valve is like you can open like how many person you can open. That type of valve all is analog. But make sure that device you are using, let's say the inverter or any device, it shows that this device is can control by 0 to 10 volt or 4 to 20 milliamp. Then your PLC can control. Okay. Very simple. Okay, any device, if it is stated that okay you can control this by 0 to 10 volt or 4 to 20 milliamp, then it's analog. So your CPU must give this value. So your graph will be, everything is same. Now the position is different. So now here will be because the CPU need to give the value, right? So means you need to do set point. So let's say you want to run let's say there is a valve, you want to open a valve 0 to 100%. So this value need to convert to 27648 to analog output. Okay, so this is now your x, because always x exists is the one variable. Then you key in like 50, then here half, so let's say 50 Hz, 50 degree. So here will be 13824. So if 13824, you will get what, 5 volt, right? When 5 volt go to your inverter, then it will go to run the motor 100% or no, it's 50%. Okay, and we do it down here. Same thing, same norm x, same scale x. What you do, this number, right, you change back to 27648. Okay, and this one you change to analog input scaling. Okay, here in the comment, no, you put it still there. In the comment, okay, AI1 equal to IW64 in bracket. You put 0 dash 27648, convert to temperature equal MD4 in bracket 0 to 150. Yes. So later on when you refer, you understand why. What is the value? Okay. So this one is analog output scaling. Okay, so now you want to put 0 to 100%, right? So no need, no decimal number, right? Okay, so what you do? You just use integer. Real. That one is so real. Okay, the last one is what? Your analog output, right? So it's an integer. Okay? So if I put a comment first, then later you try to do. Okay. Comment. Okay, you put set point equals, so just now MD4 already used. Now MD, so MW, no, MW8. Because you chooses integer, right? So your MW8 must be here. MW8, okay, in bracket 0 to 100%. Okay, convert to AO equal AO1, sorry, equal 0 to 2764. Okay, now you try to do. Okay, this one is what? MW8 what?
Which one?
The input.
I thought we had we're not taking it from.
No. It's totally different. The up one and down one totally different. It's not. It's okay. It's not necessarily the input analog input must relate to analog output. Okay. No. Last one wrong. It's supposed to what? Your Y, right? Your Y is what?
Integer.
Yes, integer, but for your Y is what? Analog.
Analog output.
Yes, you use the analog output. This one. Wrong. So I say, you just think about X and Y. Okay? X and Y. So this is not analog output. This is a set point. Okay. You change this thing. Set point. Okay, change. This one change the name to norm x2. It's just a normalizer. It's like a converting values lah, that's all. This one delete. Which one? This one, that one delete. Okay, it's a QW96. A01, A01, yes. Because you see here, so I think we didn't put QW96 here. Okay. So you see, analog value, so means you receive the analog value, which is this, convert to temperature, which is this, right? Here, you set point, so you set 0 to 100 and convert to analog. So convert to analog. So you remember like a input, normal digital input, digital output. Like I said, input only can be used at normally open or normally closed, right? Same concept here. For analog, input only can be used on this side. Okay? So output normally used for coil, right? So in this case, output will be at the outside. Means like a conversion going out. Okay? Now you try. output you can measure.
But then usually it will be I using I.
Not I. It's depend on the program. How you do it, how you program it. It's not input. So let's say, but it's based on the program lah. For example, okay. Let's say this is the temperature and this is the motor lah, motor speed lah. Let's say the temperature increase, the motor speed also increase, right? We have to do program for that. So that is where we will be learning on the compare and the move function. So we will be doing like compare the temperature. Okay, let's say 50 degree. Then I want the motor run 25 Hz. Okay, or motor run 50%. Okay, run 50%. Then if temperature 75 degree, motor run like 80%, run 80%. Like that. So it's not directly connect. Very rare I directly connect. If I want to directly connect, I don't need PLC. I give you one idea. Can I erase this? Yeah. What do you mean if I directly connect the right? It means this is the PLC, this is input, this is output, right? What do you so just now you got a doubt, right? Whether input directly go to the output, right? It means I connect temperature for to 20 milliamp, right? Then output go to the VFD, right? Let's say for 20 milliamp the same, which I do PLC. I can directly connect this to the VFD. Temperature increase directly increase. Okay? Unless you want to know what is the temperature value, then of course like you should go to the PLC. Or this one is 0 to 10 volt. But still you can for 20 milliamp directly can connect by using a resistor. You can convert milliamp to voltage directly can connect. But normally won't be in that case. Or not directly proportional. We have some differences. So will be like this. For example, let's say this is temp, this is speed. Let's say temperature is, so when it's 0, nothing lah, 0 lah, right? Let's say 50 Hz, this one 0 to 100 degree. So when it's so when I press start, okay, it's run at so let's say below 30 degree lah. Okay, I run at 10 Hz. When it go to 40 degree above 40 degree, then I run as 20, for example, like that. Let's say straight away like this. But actually this won't be like this actually. Then only straight away 40. From 40 then straight away to it's not like consistently up lah, right? Then you go to 75 degree, let's say go to 40. Then go to 10. So it will be like this, the graph, right? So how am I going to do like calculations? Yeah, difficult. So what I do in this case, that's why I say I will use compare and move. Okay, okay. Now what we do, I want to measure. Okay, first thing. You go to device and configuration. You click here, right click properties, okay. AQ, analog output, okay, number 1. Okay. Wait, number 1. What is the voltage? So, I mean, what is the type? It's a voltage, because you can choose voltage or milliamp. Okay, now cannot because you're online. Go offline. Okay, clear? So you can choose what type of signal you want to go up. So earlier is 0 to 10 volt, right? Just now you put 70 degree, 70%.
Yeah,
70% means you should get what? 7 volt. So at 0, right? So, it was 7 volt. Okay? And the 0M and the 0 lah. And top 1. This one is the bottom. Monitor and just check. Use 7 voltage DC, yeah. And again go for break. Alright, at the break, what we do a small project. First we see how it is compared first. How to use compare, then we do a small project with the compare.
Okay.
So then only you can understand why analog, then we just do scaling. Alright. Now we see how to use compare function. Okay, compare function very simple. Go offline. Let's say the same program I will put out. Okay. Let's say here we click start. Do a normal program. Start stop motor. Motor. See what name you have. Yeah, start. I think output don't have name, right? Grade 1.
Start stop motor.
Q0. Can key here what? Q0.0. Then we motor. Okay, latching. So what I want to do, when I start motor on, simple lah. So when the temperature is, let's say, reach 75 degree, I cut off the motor. Okay, for example lah. Okay. So what you do, you click here, add one more line. Okay. Then you go to compare operation. Yes. So let's say, so can you see? Equal, not equal, greater than, less than, all that.
Yeah.
So I choose the greater than line. Yes. Right. You see, the symbol like normally open, right? So the concept also same like that. It's a normally open type. Okay. Your temperature is what? Real, right?
Sorry, my what?
Your temperature.
Temperature is real. Temperature is real.
Okay, go down. Okay. Actually you can choose inside real. When this, you know, the below question mark. This question mark. Yeah. You can choose real here, or if you put temperature here, it automatically real. You can choose.
Oh.
You can choose also, or if you put on top the value, automatically.
Then.
Okay. So how much? Let's say 75. Put 75.0.
Yeah, 75.
Yeah. The value constant. Okay. Then, so this is like a normally open lah. Means when temperature is more than this, the line will activate. When temperature is less than this, the line will cut off. That's all. Very straightforward. Okay. So I want to cut off the motor. Okay. So since this is like a normally open, right? I cannot use here. Correct.
Right.
So what I do, I create a memory. I put output. Okay, what memory I can use? M1. Okay.
M1. MD8.
No.
Is it supposed to be M0?
Yes, M something lah, point. So what number? So last number is what? MD10. Right? So you can use actually 14. But I might straight away jump to M20.0. M20. No, wrong. M20.0.
M20.
20.0.
Must have point 0.
Yeah, because it's a boolean. 0.0, 0.1. Okay, let's say mode. Yeah, temperature high or high temp. Okay. Then use that here to cut off. Normally close. M20.0. Okay.
Yeah.
Okay. Download. Can I erase this?
Yeah.
Yeah.
Mhm.
Okay, monitor. Okay, press start. Okay, increase the temperature. So you go more than 75, you cut off. Okay, good. Okay. So now you see, so this is why we do the scaling actually. So because I can do like this. Okay, see here. This one is what? Greater than MD4. Okay. 75.0. Some memory lah. So I convert. I do the scaling, right? If I didn't do the scaling, can I do this or not? Do a compare or not?
No.
Can. Okay. What do? You adjust to 75, ngam 75. Okay. Around there, okay lah. Okay. You go up. Okay, 75, it means is what? How much? 1000. Oh, half, right? Okay. Half means, so I can do like this. IW64 13824. Because 27648, right? 150. So 75 means half lah, right? So half is how much? Half is 1384. Okay. So I can do like this also. Same thing, right? Because I put 75. Why? Because I already converted to 150 MD4. So the MD4 range is 0 to 150. Okay. This one is I haven't converted yet because this range is 0 to 27,000. So 75 means this one. So okay, so instead of doing this, I don't need to do this. I can use like this also. Okay. Still can go. Okay. But why we do this? Okay, there's two. Number one is if you want to show the HMI the temperature value. Okay. If you, let's say you don't want to show, so I can still can use this, no problem. Okay. But what happens is in the future, if someone want to go and modify, because for this number also you need to manually calculate, right? 75 means manually calculate. So in the future, if someone want to go and change, let's say you want to change to 77. So you go to the program and see if this is the temperature, okay, for 77. Very simple. If for this one, can, but need to calculate again and get what is 77.
Yeah.
So that is the reason we do the scaling. So after scaling, we only do two things. Number one is show in the HMI. So this temperature value I can show in the HMI. Number two is go down, this compare. Only these two we are going to do because we get the input, the temperature. So we do the comparison, then we control output. Okay? Can?
So HMI first.
No HMI. Just telling you. So why we are doing this one we call scaling lah. So why we are doing scaling? Only for two things. One, to show the temperature in the HMI, and to do comparison and control something. Okay? Okay? Now what we do? We do a simple program. Okay? You want to continue here also can, or do a new project also can. Maybe you can
Do new.
do new, but you can save as lah.
Save as.
Means what I mean is save as. Okay, therefore analog 2.
One. This one is one.
No, save as. It's a new one. Okay, save. So what you can do, all this can delete. You can redo again lah, right? Just click on the network 3, delete. Okay, network 2, network 1 also delete. So if you want to refer, you minimize, then open the other project. You know, right? Now you go back to the show all tag. Show all tag here. Okay. So from this, from number 9 until this one can delete. Okay. Save. Okay, why I asked to do this one means I don't need to redo the device configuration, all that. Need to add the PLC, all that. Because tomorrow we do like a project. Okay. Now, very simple this program. So simple but it's tricky. Okay. Let's say I have a start and stop. I have a compressor. Okay. I just want to control the compressor using their pressure. Okay. Using the pressure. Okay. So let's say the pressure sensor is connected to your analog input 1. Okay, and the pressure range is 0 to it's called 1 because 1 bar is how many kilopascal? 10,000 kilopascal. 1 bar.
1 bar. Yes.
10,000, right?
Yes.
1 bar.
Pascal. 10,000 Pascal.
10,000. 100 kilopascal. 1 bar is 100 kilopascal. Okay. Let's say the pressure is let's say 2.5 bar. It means 250 kilopascal, right? So I don't use 2.5 because 2.5 is very small number. So if bigger number is okay. So kilopascal. So means what do you need to do? This analog value convert to this value. Then I have two set points, that is cut in and cut off. So the cut in pressure must be less than 200. Cut off pressure more or equal to 225. For example, both also kilopascal. Now, very simple. Start. I make sure what is my current pressure. These are two set point. Two set values. Means like a comparison values. Okay. When I start, I on the compressor. So this start stop you already have, right?
Yes.
Then this one you put Q0.0 okay? Okay. So when I start, compressor on, but before on, I make sure my current pressure value is less than 200. So I on the compressor. So when the compressor is on, the pressure will increase, right? So it just increase lah. Use the increase. If the pressure is more than 225, cut off. The compressor will off. Okay? When compressor off, pressure decrease. So you decrease the pressure. When it go below 200, on again. Compressor on again. Okay? So it's just on off until you press stop. Okay? So the flow chart is when I press start, I have two conditions. I start at the same time, the pressure value must less than cut in. Okay? Then only the compressor is on. So when the compressor on, the pressure will increase. If the pressure value more or equal to cut off, the compressor is off. So when the compressor off, pressure decrease, right? So you can go to this position. Okay? Then if I press stop, the compressor off. Okay? Okay. Fine. First thing is, okay, what I want to do, you do like a proper program. That is, don't do in OB1. You do one FC for scaling. Because you need to convert this to scaling, right? Okay. So one FC for scaling, another FC for this program. Okay, okay. Try and see.
So only for scaling, I do it in FC, the rest OPM.
No, 2 FC.
Everything in FC.
So 1 FC for scaling, create another FC for program.
Okay.
So no need to do program in any server.
When start, the cut-in pressure must be below 200, or else compressor will not start.
Yeah. It's a condition.
condition they find is what was the issue? When I want to test.
Where no condition? Where? Okay. Your compressor and the pressure scaling is what?
Oh, they're both done in main.
Is it? Not calling the main, right? Right. So very simple, how to know? Very simple. You go online, go to FC. If you're not seeing the color, green color, double click. If you're not seeing green color, monitor. Okay, if you're not seeing the green color on the lines, there's only two possible. One is PLC stop mode, or this one not following the OB.
Okay. close, cut in pressure and cut off pressure is open. It's open before I even start.
Open means not you are using normally close, okay?
Normally close, but I start the time it's already open. That means it's break. And it already break even though it's normally closed.
Okay. Why? From where I get? Which one?
This
Yeah, because you said.
okay, but I also got this. How come it didn't activate? So mine is when within this, right? Within in between this, you will reset.
Okay. Now is what happened is something like reset and set at the same time. Okay, this one is not working. This one is
Okay.
in between. So
Okay, let's say I use that.
no, okay. You know what's the problem? Go to your scaling. MD0. Go to compressor. M0.0.
This one use 0.5.
No, some other zero lah. Some other memory. M0 can use. 4 also can use.
So 5.
5 can use also.
No, MD, sorry, size one, MD0 and MD4. So M0.8.
No.
M0.
No. You already use MD0, right? It means you cannot use MB0. Okay, I put it like this. Then you clear a bit again. You already use MD0, okay? It means MB0 plus MB1 plus MB2 plus MB3, right? All these cannot use. It means M0.0 until M0.7, M1.0 until M1.7, M2.0 until M2.7, M3.0 until M3.7. Cannot use. So you already use MD4 also, right? So if 4 means next available number is what?
Yes. 5, 4, 5, 6, 7, 8. 8.8. M8.8 available.
8.8 cannot buy. 8 and 0.8, 0.9 cannot. Maximum 0.7 only.
Oh, N9.1.
9.0.
Never. Like that, I just put MD. It would be easier if I just do MD, MD8, MD.
Cannot.
This memory cannot put MD
Cannot.
because MD is
MD is double integer. But in the set, I need to put a boolean.
if it's just a column.
Call also boolean. But this one normal lah, this one. Need to practice lah, right?
So actually you have to go and count if you want to use the memory.
No need to count lah, just see okay what memory you want to use. You already use MD10, MD4 and MD0 and 4, right? Next number is available is what? 8. So 8.0 can use. If no,
Oh, 8.0. Wait. Okay.
because you're using 4, right? 4, 5, 6, 7.
Yeah. So when it is outside the pressure range, it cut. But then when it goes back into the pressure range, does it auto start?
What's that?
You need to auto start.
Auto start.
So when you go back to the range, you need to trigger start.
Yes. That is the tricky part. Actually, this one, when you start, okay, just press start.
I think I'll just do one more latch.
I'm not sure. I'm not sure. Okay, wait. So,
So now it's really
no.
Right?
Must be below this, then only I can start. Right?
Oh, is that what it is?
Yeah.
Uh,
Not in the range.
below only can start. If
But now it's below cut off already. It's supposed to be below, then only can start. Actually, you go up. Actually, this one right must use normally open. Means when it's below, this one energized, right? You use here normally open, means then only can start. If above, it will cut off. Okay. Then you go to above 225. So this one you go up, will cut off. Then again you need to start again. Right. stop?
Oh. Okay, when it's below the pressure and the stop, yeah, that's fine. Found that and stop. But if I'm above, then it will. Yeah. Okay, let's just say that. Start.
Okay, okay. Alright.
And then now below pressure. So it enter the pressure range is still.
Yeah, yes.
And then when you go above,
Cut off, okay.
Okay. And then now it will stop. It, well, yeah, it will stay stopped. But then
If you go down,
go to the pressure.
okay, make it simple. Very simple. That's why I say initially I say it's going to be complicated, right? Okay. You follow this, I start, I compare this, okay? I start. Actually, I straight away can compare here itself. And pressure, right?
Yeah.
Pressure, how much cutting just now? 200.
200.
Okay, so I want to latch, I need to latch after this. Correct or not? You know why? Because I start compressor on, because it will go above 200, right?
Yeah.
After 200 only need to cut off. So if I put it here,
You'll cut.
more than 200 cut off. Then PV compressor off. So I can use compressor as an interlock if you want. If I want, if I don't want, no problem. $12.20.
225.
Here memory, okay? So I put compressor off. Okay. So this one done, normal start, compare, compressor on, more than compressor on. Okay, now I want to repeat. If I want to repeat like just now what you do, right? Can do also. Okay? Or if let's say I don't want to use this, right? I can do something like this also can. Means same like you lah, right?
Yeah.
Same like what you did. 200 then compressor on. Then instead of using this, I can use this also can. Same like what you did lah. Okay? Now how to repeat? So something need to contact, right? Okay, so when the pressure become less than 200, so if I put it here, like what you do, pressure become less than 200. Okay, let's say compressor on hand. This one you take it and put it here. What happened? Before you start, it's already done. So instead of doing that, when it go below 200, what happened actually? This one turned on, correct? But it's just waiting for my start to give signal. So if I do something here, compressor can on back, right? Means when if the start button now, if I press and hold, it can repeat. Correct? Right? It can repeat. We know why? Because you see, the start button, if I press and hold, always give signal. Temperature less than, okay, on. Temperature more than, okay, cut off this. After this one can cut off, right? Then if temperature less than 200, can on back, okay? But I cannot press and hold the start button. So what I do, I take the start button, compressor run, take the memory, memory, compressor, then stop. So what happened? I take this one, I put it here. So means when I start, then only this memory on, then only less than get off, more than get off. So you can repeat until I press stop. So if I stop, this one will on. This one will on or not? No, I mean this one is this one is off, right? This one not off, right? Because it will only off this.
Yeah.
If I already latch, I won't off. So put the same stop button here. Anyway, can go out this one also.
uses the compressor run does not need a latch. Anyone below that uses it wouldn't need a latch.
Which one?
No, up one.
Below here. No need.
Yeah, so like for any other network, down there who uses comp run in front, don't need a
No need.
latch. Okay.
because whenever I teach you, you understand. Okay, some training, participant will understand. Some more like advanced training. Sometimes after the training, you feel very tired. The entire body, like you work for, like you do some heavy work because the brain, too much of work in the brain. Sometimes not every day.
Why some of your participants like that?
I know they are not advanced. Sometimes they don't understand, so need to clearly explain.
Yeah, but
sometimes
a lot of this just need to go and remember. I mean, understanding is one thing, but also need to remember, especially
Then what? Remember, you need to practice. If you want to remember, you need to practice. For me, if you ask me, for example, do I know how to do like the OPC next week training? OPC, I know how to do training, but I forget training. That's the issue. So
too long already.
long time already I didn't do the OPC trainings. So what I do, I have two days weekend, right? I need to practice. Go to YouTube. I know what the software need to use lah. So need to go back to the YouTube. And normally what I do, I will create my own manuals, like what you're doing. So let's say anything got so many steps, so that I create my own manual for myself.
Yeah.
So during training, if someone okay, I can use that.
Yeah, very necessary.
Yes, yes.
If I read other people's manual, sometimes I'm confused.
But one more thing, you need to be clever with reading other people's manual. That is very, very important. Not other people, I mean the original manual.
Oh.
That one is very, very important. To read and understand that.
There's a lot of
Functions, all that. This one also I see just now. I never buy a new one. Last time also for a project I did some programming lah. But that one also is already programmed, some programs. So they asked me to add some programs, so I added. Okay, so this is the first time I buy a new one. Okay. So when I want to try to download, cannot download.
because the
First
file-
thing, no memory card.
Oh.
Okay. So I didn't notice. So I'm not sure whether need to add a memory card or what. Okay. So what I did is go to Google and check. Why cannot download? So they say S7-1200 need memory card. Okay. So I use one of my old memory card, cannot. Because the old memory card was programmed one. But we can see here lah, because it shows not working, all that. Then I tried to format it memory card and I tried to put it second also. So I just take a new memory card, put in, can work, right? So I know okay, can work. Then the older memory card I just take, put inside here, format using the software. Earlier I format using the my card reader.
Oh, not enough format using card reader.
Cannot.
It's format using software.
Software. Because when you use card reader to format, it become like a memory card, like a corrupted like that. So when after format I put it here, it's not working, it's not reading the memory card. So what I do, I put back to this PLC, power off and on, then only can. So I just format, clear the memory. Then I just create a simple program download, can work. So some data, some steps I know, some steps I don't know, right? I just go to Google.
Yeah, need to actively research.
Find out. Find. The thing is, you need to know what keyword. The keyword is important. Now this one, Google is say this one is for S7-1200. Google they say can work, but not working. Cannot connect.
What thing? This thing. What is that thing?
This one's the back plane.
Oh,
For 300 is something like this big one.
it's a.
It's a rack.
It's a
It's a metal rack.
Yeah.
So where you can screw it to type inside. So the earthing, right, they will connect here. So if a lightning or something is short, so it won't affect this because of earthing.
Okay.
That's the reason. So that's why this one all earthing. So what happened? This one for S7-1200 one. But they say can use for
Google say.
Google say lah.
But then
Not also. But because the Google say can use the same part number. Just try cannot. Then I Google and see there's another type. Different part number, so must use that.
Oh, you did buy again.
No, I don't like it because this one just one unit, whole unit. If I want to add at the side something, then only I need to buy. But I don't want because it's already whatever I needed is already there. CPU, analog input output card, digital input output cards. This one not screw type. This one is just slotting side.
Sorry, that one is
S7-1200.
But then I thought you said S7 usually comes with CPU input and output. This one.
No, only this model come with the together because it's a 1215C.
Oh.
Only one model. The rest of the model only CPU only.
But this one.
It's a compact. It's a CPU come with the I/O. 1200 all the model is same like that.
Oh, 1005 is not.
1005 only one model is come with the I/O. The other models only the CPU only.
So like 200, 300 all CPU.
200. 200 similar like this.
Oh, also compact.
200 all the 200 is compact. 200 and 1200 all compact. 300, 1500. One or two model is compact. The rest of the model is a modular type.
Oh, okay.
The rest of the model lah. Only one or two type. Two model is compact like this lah. 400 is all modular type.
Which one is the newest model?
Which is the first one? 1005 and 1002.
Oh, okay. So. Oh, but okay. Now I see. Because I thought those that are only CPU are the older models, and then
No,
eventually become compact.
No.
Not like that.
Not like that. Depend on the usage lah.
Isn't it better? Like not everyone wants compact. Isn't compact the best?
No. Because compact only can support few IOs.
This one only two.
So only two. So maximum how much you want to add. Then this one can use remote IOs, means remotely some IO can add using Ethernet, some IO lah. So that one also maximum. So can go maximum how many? Few hundreds only input outputs. But this one can go up to 1000 input outputs. The memory speed.
1000. What kind of machine needs so many?
So many IOs lah. Like you want to do monitoring system, the whole plant you want to do some monitoring or something like that. It's so much of IO.
Is it one production line?
Yeah.
They have multiple PLC at each station.
Or this one, you know what? Can do this one, even the 1002 also lah. Can do something like this. Okay, this is the main CPU one. Main CPU. Okay, and some IO. This one for all lah. S7-300 or 400 or 1002 or 1005. All can support this. Then from here I go to one remote IO, that is ET200. It's a remote IO, remote input output in some other places. So this one got some IO. Example lah, IO. Okay. Then another set. So what happened? So the CPU is only one CPU, the main. This one is remotely in other place I/O. Okay, so this one will control the main machine. Let's say water treatment example. You know water treatment plant, right? They do water treatment. I mean the wastewater they treat first, then only they release to the river or that thing. Then this one, because the water treatment, they will have a few tanks or that. This one for the tank 1, this one for the tank 2. So all the tank 2, so this one will be near to the tank 2 panel, this panel will be near to the tank 2. All the tank 2 I/O, the pH value, the pressure, the flow, everything, auto, everything, level meter, everything go to here. Same thing go to here. But the program, where I do the program? Here I do the program.
So it's for, no, this one is compact. It's not for this kind, it's for only CPU and that.
That's why I say 300, 400, 1000, 2005. All the models you can use. You just forget about this compact all that. Even that one also can do that.
As long as they got the Ethernet cable along.
Yes, Ethernet cable or Profibus cable can support all that.
The computer can, the computer is powerful enough.
If powerful enough, the memory is enough, the I/O can support, can do that. Okay, like I said lah. Okay, so you see. So what happened? What they do here actually, the 400 they upgrade to 1500. The 300 they upgrade to 1002. Make it smaller and 1002 lah. Okay. So what happened is, so if you compare to these two also, it's also modular type. So modular, right? It's also modular type. Okay. For this only one model is compact like this. For this also only one model is compact. This one is all the model is compact. This one is all modular. Okay. So these two is for bigger systems. These two is for small systems. Smaller systems, smaller controls. But still they can control hundreds of I/O.
The computing power is still there.
Yes, computing power is there. Then for example, depend on how many motor they can control. So for example, like at 300, not mistaken, like if you use Profibus, it's only 30 motors you can control using communication. Okay, not mistaken, I forget it. With this one, I think 128 motors.
Oh,
Many motors. Okay. And another thing is 400 and 1500 can do redundancy.
what's that?
Redundancy means you use the same CPU. Okay. Then so this connect. Let's say a router, right? Okay. Connect here. This one connect here. Connect here. So this one called. So this is main. This is the redundant. Okay. So what happened? The main will control all these I/Os, everything, all these machines. So the same Ethernet connected to a VFD, all that. I have a company project actually. How it looks, how big the program. So VFD, all that thing. So this one will control this. If let's say this one fail, corrupt, some problem, automatically this this one will take over this. So what happened is the program inside here and inside here is exactly the same. You do one program, you download here and also here. Then you need to set this as a main and this is as a redundant. So if one fail, the redundant will take over. So if the main is already okay, then the main will take over. So this system normally they will use for any system like oil and gas system, oil and gas safety system. So this 24/7 must run. So this one, this redundant system only can do in 400 and 1500. So let's say you want to control only like 40 input, 40 outputs, where you can do 1002 also can use. Okay, but that system need redundant. So you have to go for 1005 or 400.
I don't think. I mean, my plant uses Mitsubishi, but I don't think we have big ones like this. And yeah, definitely no redundant.
I know. And normally what they do?
Oven heating the spring.
Machine.
Yeah, machine.
You are manufacture the machines.
Oh no. We
Then?
manufacture spring for.
Oh yes, sorry.
Yeah, spring.
MDM, right? MDM, sorry.
Yeah, spring for the truck, industrial truck.
Okay.
So no if it
Ah,
is
no,
down there,
that one is not only.
There's no safety concern.
Yeah, safety concern will be there, but it will be. But that kind of machine no need 24/7. That one you press start, all the value is the heat up this one, spring everything.
Yeah.
So that system, that one can control, can use any PLC. No need to special all that.
Yeah, no redundant.
Yeah, no, not necessary. Redundant normally will be in chemical companies.
I guess food also.
Food maybe, I'm not sure. Maybe.
Yeah, makes sense. Because cannot suddenly stop.
Cannot suddenly stop. You stop. It's dangerous. Even this one, power plants. Power plants all using redundancy. They must use, no choice.
Do you have any clients that use it?
What? I know. The power plants.
Oh, those.
Power plant, because last time I participant from power plant.
Do you do troubleshooting for any?
No, I never done troubleshooting. No, because normally you see like these big companies, what they do, they have their own vendors, registered vendors. So they don't go for others.
Those
Machine makers.
professional licenses.
So they want all license. So they are the one like supply. Or sometimes what happen is they buy machine from China. Europe, example lah. So what happened? The Europe company will have a service company here.
Okay.
So this company will go and do the servicing and everything. So they have their own SI and all that.
My company, we won't go for the expensive service. Whoever cheapest we take.
Yeah, normally I will get some company something like that. Right?
Yeah.
So they will just check, hey, who cheap, you come.
Quotation first they come.
If quotation, okay, you can solve, okay, you can come. So normally I go and troubleshoot all small. Big companies means sometimes they come for training. So they know me all that, so they say okay. So that they call me for troubleshooting, like that I have a few like big companies like here I have one company. I have done so many projects for them also. Caddy. It's a food company also.
What's the name?
Caddy ingredients. Here. Like them lah. They do ingredients like powders or that. So the guy who always he's a software engineer, he's a PLC guy also. But he know LMW. So he only do LMW. So if any problem with Siemens or Mitsubishi or that, he will call me. So since I think I am doing for him since 2000, for me personally I'm doing since 2016 Then before that also, you know, my boss Actually, I can explore, but the thing is nobody here to do the training. If someone will do the training, I can go and explore, take some big projects or that.
You're the only guy. So you guys
Training.
trainer?
I'm the only trainer.
Oh, I thought that there were two people. I remember I read the company profile.
No, this my boss is already retired.
Oh, the other guy is the boss.
Yeah, my boss is already retired. So now currently I'm doing the training.
Company not doing well.
Hmm?
Company not doing well.
Doing well, but I want to take projects. That's the thing. So last time I have one guy, so he worked for 1 year, then he left.
Oh, why?
Because sometimes here, not every day got projects, right? Sometimes training, sometimes he had nothing to do. So we saw, okay, learn something. Then he said, okay, I'm going to go for company. So we go for company. Learning.
Yeah. I mean, for me as well, I also want to challenge my company. I feel like as someone in the project team, you don't really do a lot of hands-on work. A lot just research. When I want to buy a new machine, what I do is go and study the current one, things like cost, how many cycle time, the labor, electricity consumption, and then the new one can save how much, better in what way. It's just things like
So
that.
more on buying the tools, so you have to research on the tools lah.
It's not tools, it's machine.
Machine,
Yeah, but things like that, and then also project planning. So when you want to buy a machine already, okay, you need to set up the space, how much space you need, the forklift can come in or not, what piping you need, how much electricity you need for this and that, and then just things like that. But then always, right, after you found out already, you need something to be done, right? It's either you call vendor or you ask maintenance. So never done anything by myself before. Actually
Hands-on lah.
never. Yeah, so it's just not good.
But normally that's the job of engineers. If you work in industry,
Big industry.
because you see, because I finished my diploma, then I joined here. After that only I do my degree part-time. So all of my friends, they finish after diploma, they usually went to join the degree. Then they finish, then degree. So now they're working at company. So most of the time their work is like, okay, I have a problem. Let's say like maintenance, one of my friend maintenance. So whenever machine is problem, okay. So he will have his own technician. So the technician will do the job everything. So for him, the system will have a manual everything. You refer to the manual, okay, and tell him, okay, how to troubleshoot. So he will join the troubleshooting, for example, now. Maintenance guy, he will join the troubleshooting. But most of the time, he won't be hands-on. So the technician will be hands-on. Then, what the engineers normally will do, okay, try to improve. Okay, I have a system. So what improvement I can do? So this one always break down. Okay, what are the improvements? Okay, try to do the check. Okay, do the presentation. All okay. So his job is okay. Like you say lah. So let's say I have a machine I want to improve. So I just study about the machine system everything. Okay, I check. Okay, then this one need to. Let's say lah, this one need to add a inverter. So this inverter not good. You need to add this inverter. Okay, everything is good. Then you need to find people who do the inverter. Fix the inverter. Then after that finish your job. So they will come and do. But you need to be there. Everything all must have a report. Everything is documented. So normally until then only the engineers. If you go to manager, let me tell you don't have hands-on.
It's true. I understand that, but then the thing is, if you don't touch before, you wouldn't know.
Yeah, of
so
course.
so let's say like you say troubleshooting, he asked technician to do it, but then if he look at the problem, he also don't know.
Yeah,
it's
that's
a
the
problem.
thing. So the best thing is joining like a company like a vendors. They are like a vendor company lah. So they are the one normally hands-on, you can learn a lot. Actually, I tell my friends whenever after they finish degree, because before they finish degree, I already have 3 years experience, right? So I tell them, you go because I work here. It is very small company, not every day troubleshoot, only once in a while. But whenever I go company, I know. Then I tell them, before you go to big companies, you join some company like this, small companies first. You learn a lot of things. You only go deep, okay, a lot of things. So you know how the company, what are the things they are using, everything. Then maybe a 6 months or 1 year you work, then you go to company. So at least
the technical skill.
technical skill you have. So very fast you can grow.
Yeah,
One of my friends did that.
Yeah, now I realize it's good. Because if you don't have technical skill, you join big company right away, they let you do all the stupid job first.
Yeah,
Yeah.
mostly
They don't even want to teach you. They just you do this.
That one nothing lah. They won't teach you.
Yeah. Like this whole, I want this training also so hard to get. I have to pay by myself. Yeah. And then he actually when I joined the job, he told me that one of my responsibilities would be troubleshooting PLC, but only for the like the new machines that come in, the ones that I planned for them to come in. 2 machines come in already, I didn't get any chances because of course first of all I don't know PLC, and I thought he was going to put someone to train me, but I guess
No.
Yeah, he didn't. And then secondly, already 9 months, and then I took the initiative. I told him, okay, I want to learn PLC. I submit application, for him to approve. He didn't approve.
Then it's better to join another working environment. Working environment is very important.
But he's okay with me. He's actually okay. It's just he's
Some like this lah.
calculative here and there.
Yeah.
Yeah. So now I pay out of my own pocket and I'm gonna leave soon. Yeah.
It's worthy. This training is worthy.
Yeah. Actually,
Even though you are not going to assemble, not going to do trade projects, or at least you know what the PLC can do. So whenever you do, when let's say next company you go, so you tell them I know PLC, okay. So whenever you see PLC, whether you see the panel, everything, you know what is happening there.
Yeah.
So you know how to do troubleshooting, okay, do something, okay, get the program first, get a backup program. Whatever software, no problem. Just go to Google, check whatever software. Nowadays very easy. Take picture. Nowadays the Google Lens or something, right? Take picture, you can tell you what is the PLC, everything.
Yeah.
So just take picture or something, Google, get what the software, go and check and see whether the software can find or not. Then try to back up. What cable you're using, everything can Google. Or you can WhatsApp me also, no problem. So I can tell you. Because you see, every day, nowadays, last time, okay, nowadays, every day I will get some of my participant message. They ask something, they ask, okay, can you send quotation for next training, this, that. Just now also one message.
Oh, every day. Good luck.